A very good afternoon to everyone, and welcome to this program on Phenome India. Kindly keep your mobiles in silent mode. Shortly, we will be starting the program. Respected Professor Sunil Kumar Singh, Director CSIR-NIO, Dr. Vinay Nandikuri, Healthcare Team Director and Director CSIR-CCMB, Dr. Saikat Maiti, Director CSIR-IGIB, Shri Rajendra Prasad Singh, Chief Scientist and Head IMD, Dr. Shantanu Sengupta, Project Investigator and Chief Scientist, IGIB, distinguished directors, enthusiastic coordinators, esteemed guests, staff, and students. Greetings to you all as we gather here on this occasion. Phenome India is a pan-CSIR cohort study on human health and the risk of lifestyle-related cardiometabolic disorders. These studies are being coordinated by CSIR, IGIB, and all the CSIR laboratories are a part of it. We miss the presence of our DG CSIR, Dr. Kalai Selvi, who due to sudden need of her official presence at Delhi, had to opt out at the last minute. However, she has sent us her message, which will be screened later. To say more on this eventful afternoon, we will start off with the screening of a movie on Phenome India CSIR Health Cohort Knowledge Base. Wish you all a pleasant viewing.
Phenome India CSIR Health Cohort Knowledge Base is a long-term cohort study initiated by the Council of Scientific and Industrial Research to identify India-specific risk factors for cardiometabolic diseases.
I'm very happy to be a part of Phenome India project, which is recently initiated by CSIR to benefit basically the CSIR employees, including pensioners and their family, in terms of healthcare, which in turn will be made as a complete program covering the nation's requirements. I wish every success for this cohort study. I appreciate, congratulate, and I wish them all success, not only to the core team, but also to the extended team, because there's a huge number of scholars as well as scientists, apart from the leaders in the form of directors of few laboratories, are involved in this very important exercise. I congratulate each and every one of you, and the support from CSIR headquarters will always be there, because the ultimate aim is to ensure that we should have a very perfect, very precision, predictive, and also personalized medicine that should be made possible in the country. So we can call it as 4PM, and therefore this 4PM will become a reality through this cohort study, and my best wishes are always there.
For disease diagnosis, currently we consistently use markers that have been developed in Western studies, and it is increasingly being clear that such markers have limited value in disease diagnosis in our country. CSIR's Phenome India program is the first step in this direction. It is the first and only pan-India longitudinal study aimed at developing India-specific risk models.
Cohort studies influence public health policy by identifying key health trends and risk factors. The outcome of such studies help us in developing guidelines, prevention programs, and allow us to come up with resource allocation strategies for future.
Longitudinal cohort studies provide key data on the incidence of disease and risk factors by following subjects over a period of time. Not only do such data help understand current trends, but also point researchers to new and emerging factors that affect health.
The PI-CHeCK, coordinated by CSIR, Government of India, is one of the important activities, cohort-based activity, which is likely to contribute to the objectives of National One Health Mission?
I think this cohort will allow India to be one step forward in the area of precision diabetes and cardiometabolic diseases.
Phenome India project is a very unique project. Why? Because all 37 laboratories as well as all the unit of CSIR are involved to execute this project.
So another great advantage of this PI-CHeCK Phenome India cohort project is it will enable us to furthering the efforts of precision medicine in the country.
So, what are we doing in this project?
In the Phenome India project, we are basically evaluating a number of modalities to assess the phenotypic compositions. These include lung function assessment through spirometry and oscillometry, liver elastography, body composition analysis, and HRV analysis through a long lead ECG recording.
Genomic content of an individual is the base over which factors like lifestyle, nutrition, connections, etc. act and lead to development of multifactorial or complex diseases. Understanding these genomic signatures, therefore, is an essential step towards first-place management of health and disease.
So in this project, we are looking at adverse cardiometabolic outcome in patients and in this cohort of CSIR employee, pensioners and their spouses who are at least 5 years.
Metals are very important for growth and development of organs. The surplus or deficient of metal ions may lead to disease and recurrence. Keeping this in view, we aim to analyze around 30 metal ions in human serum using HCPMS.
We are also sequencing gut microbiome in more than 5,000 samples.
The CSIR Phenome India cohort is one of the largest studies on gut microbiome in Indian population.
The first step was to create a portal for the registration of the participants.
So for the successful onboarding of the participant in this portal and the project, we have launched the user-friendly as well as the secure portal known as the CSIR Cohort portal, which was launched in November. We have mainly taken care of the fundamental aspects of the registration of the participants, their slot booking, data acquisition, as well as the return of the results.
One of the most important activity was to raise the awareness among CSIR personnel.
As a participant, some of the basic questions that we tend to get are, what is the study about and how is it different from the routine medical checkups that we usually get done in the hospitals? What are the additional benefits that I get for participating in such a study? And what happens to my data, especially that a lot of personal and health related data is being collected. To address this, we have conducted several awareness campaigns across all CSIR institutions where we encourage participant interactions to address these questions related to benefits as well as privacy concerns.
The first phase of sample collection started from 7th December 2023 at CSIR IGIB and now has concluded at CSIR-NIO on 2nd June 2024.
We have ensured efficient supply chain of consumables and equipment through tireless efforts of our logistic management team. Furthermore, our volunteers have ensured timely delivery of sample collection kits.
More than 45% of the volunteers who have contributed data and samples to the Phenome project are women. I'm very excited about the possibility that we can now ask questions that specifically pertain to women.
A state-of-art biobanking facility for the long-term storage of human specimens such as plasma and serum is required for high-density storage of well-characterized biological samples, and such facility is a backbone for any longitudinal cohort study.
Phenome India project is a project which aims to record, catalog the molecular diversity. The scientific endeavor begins to catalog the molecular diversity of the Indian population.
The Phenome India longitudinal cohort aims to utilize artificial intelligence methods to understand the complex interplay of genetic, environmental, and lifestyle factors towards personalized medicine in the Indian population.
It allows researchers to uncover complex relationships among the various data types that we have.
The digital transformation of India is opening new directions in everything, including health. However, things like the Ayushman Bharat Digital Mission need to be supplemented by high-quality research-grade data collection that runs over decades. That's where Phenome India, led by CSIR, will make a very, very valuable contribution towards making us a data-rich, disease-free nation opposite of where we are today. My best wishes to everybody in this cohort.
This is a wonderful initiative for the CSIR. It gives an opportunity to the staff and scientists of the participating institutions to get aware about their chronic disease risk factor status, so it's beneficial at the individual level.
Phenome India is an ambitious program of CSIR. In this program, through the CSIR lab that are spread across the country and truly reflect the cultural and geographical diversity of a country, we get the clinical information about individuals, which will be extremely useful in setting the baseline of our population, and it will go a long way in defining the healthy individuals and setting up the policies and a better and efficient healthcare system for the country.
Let us see what a medical fraternity has to say.
In 2011, I observed a sudden rise in the cases of hypertension and diabetes, and the scenario was not different in the other labs around. At that time, a thought came to my mind that what if all this data was put together, there was a great potential of coming out with a great study across the country. And today I can see this happening, and I'm very much glad to be a part of it.
We have been following Western data, Western reference values, and this PI-CHeCK will really help us in generating our own reference values. It will also help us to link various risk factors like body composition, liver fat, etc. to the diabetes and cardiometabolic risk.
In Bangalore in 2006, out of 1,174 cases, 18% of all stroke patients were below 40 years. A greater prevalence was seen among men with a male to female ratio of 2:1. Then a thought came to my mind, what could be the scenario across the country? The Phenome India project initiated by CSIR definitely helps finding such scenarios along with various health related risk factors. We are proud and happy to be a part of such study.
Involving with the project, my experience has been both challenging and rewarding. Witnessing the project evolve from conceptual stage to a functional knowledge base has been immensely satisfying.
And at CSIR, under this program, we had about 470 registrations, and in a one day we could register or we could test the participants up to 80 numbers, which is a sort of a record in this entire sample collections. And we saw the huge participation from all ranges, from pensioners, regular employees, and many of the participants traveled from different cities also, like Bangalore, who came specifically for this program.
I think this is a very important outcome of this entire project and study, wherein we are now more conscious about our health and we will not ignore it, and therefore leading to healthy staff, healthy families, and ultimately a healthy CSIR.
Surely the movie has enlightened us on the different aspects and relevance of Phenome India. This initiative of the Council of Scientific and Industrial Research gains significance as it deals with understanding and determining the risk factors that might lead to complex metabolic disorders. Creation of a biorepository, a step towards developing India-specific normative values, equations for various health parameters and modalities not available in literature, and a step towards development of diagnostics by utilizing the knowledge generated through these essays and analysis. This very unique program is specifically aimed to integrate state-of-the-art AI/ML models with comprehensive health data, laying the foundation for precision medicine with personalized disease risk scores, and thus moving towards raising health standards for the present and future of Indian population. I now have the pleasure to invite our dignitaries on stage. I request Professor Sunil Kumar Singh, Dr. Vinay Nandikuri, Sri Rajendra Prasad Singh, Dr. Saikat Maiti, and Dr. Shantanu Sengupta to please take your seats on stage. Thank you, sirs. I request Director CSIR-NIO to accord a warm welcome to our dignitaries with potted plants. Hearty welcome to the Health Team Director, Dr. Vinay Nandikuri. To Head IMD, Sri Rajendra Prasad Singh. Welcome to Director IGIB, Dr. Saikat Maiti. Welcome to Dr. Shantanu Sengupta, the project leader of Phenome India. Thank you, sir. I request Dr. Shantanu Sengupta to present Director NIO with a potted plant. Thank you, sir. I now request Professor Sunil Kumar Singh to welcome the gathering.
Good afternoon, everybody. Respected Dr. Vinay Nandikuri ji, Director CCMB Hyderabad, Dr. Saikat Maiti ji, Director IGIB Delhi, Dr. Rajendra Prasad Singh, Head IMD CSIR, Dr. Sengupta ji, PI of this project, directors from various laboratories of CSIR, heads of different departments of CSIR, all the scientists and students involved with this project, my dear colleagues from CSIR-NIO, ladies and gentlemen, it gives me immense pleasure to welcome you all in the program, this Phenome India Unboxing 1.0 at CSIR-NIO Goa. At the outset, I am very much thankful to the CSIR, head of our CSIR family, and the project leader of this program, Phenome India, to hold this entire program at NIO. So thank you very much. I strongly believe that the Phenome India program of CSIR is a powerful step toward providing a quality and personalized health care to each individual in India. I'm surprised to learn that till now such activity has not been taken place in India even after 75 years of our independence. The cardiometabolic diseases which are rampant in India and which is keep on increasing, for example, the heart-related disease, liver-related disease, pancreas, lungs-related diseases, which are very much increasing. The treatment which we provide is based on the survey, health survey, which has done on Caucasian survey, I think Caucasian population. We are very much aware that our racial system, food habits, climate, environment, etc. are very different to that of the Caucasoids. So therefore, there is an urgent need to have health survey done on Indian population to devise specialized and personalized treatment against these diseases. Several countries have already done that. For example, you can talk about UK Biobank, China Biobank, American Biobank, etc. In India also a few of the group has done this, but I think at national level this will be the first effort. And for first such large effort is being done by CSIR to have genomic, proteomics, gut microbe, all this survey on our Indian citizen at nation level. I think this is very much important because our CSIR laboratories are spread all over country, which will give a detailed study of our means the data which is available, which is required for the personalized studies. This will provide a great help in devise a personalized treatment for our citizens. I congratulate the entire team of CSIR for completing this first phase of this survey. Once again, I welcome you all and wishing you a very fruitful outcome of this project. Jai Hind. Thank you very much.
Thank you, sir, for your address. I now invite Dr. Saikat Maiti, Director, CSIR IGIB, to deliver the opening remarks.
Good afternoon, everybody. I am really happy, to see a lot of people are here for the event, Phenome India unboxing. I am really thankful, first of all, to all my fellow directors, HODs, my friend Anurag, Rakesh, with a small sort of notice, they have managed time to come and extend their support for this project. So when Shantanu, came to me regarding the sample collection, which was happening in NIO till yesterday, day before yesterday, that we are going to cross 10,000 landmark, and he only proposed that we should plan something to celebrate. Then definitely we need consent from our DG madam. I similarly proposed her, and she also was very enthusiastic that yes, we should celebrate, and we should celebrate at NIO. Immediately I knocked Sunil's door, that send him a message, and immediately he gave me a call back late night. That day he was in meeting whole day, and he agreed, readily agreed, yes, we should do it. So again, I am really thankful to Sunil that he has extended all kind of cooperation to hold this meeting in NIO, and I don't think any such problem is there that we should consider. So all the arrangement has been done by NIO team, and on behalf of IGIB, I really extend my gratitude to them. Also, I am really thankful being a nodal institute of Phenome India. When we have started, we really didn't know. Actually, I didn't have any idea about this kind of phenome study. I just got to know from my friend like Chandak, Santanu, that cohort is a very important phenomena of health research. So when this project was getting conceptualized, I was not director at that moment. As a scientist, I used to participate and try to argue whether really it is needed or not needed, spending so much money. Then I realized that it's really important. And we have crossed to collect health data of 10,000 individuals, but this is the starting. That's what I understood. Because analyzing the data is basically objective of this proposal, not the collecting the data. Yeah, there is an output that collecting data is helping some individuals, but this is not the objective. Objective is actually going to start now onwards. And that's the genesis of today's meeting, Phenome India Unboxing 1.0. So with this, I will end here, and thanking all the coordinator, participants, volunteers, those who has spent their time to collect sample, going one city to another city without any complaint. So I'm really thankful to all of them, being a nodal institute. But I believe we are the coordinator, but all CSR labs are really participating in this project, and their support also is very much important. I already got that kind of support. I also expect next phase of research of next 4 years, I will have that kind of support. With this, thank you all. Jai Hind.
Thank you, sir. I now request Shri Rajendra Prasad Singh, Chief Scientist and Head IMD, to brief us on the genesis of the project.
Dr. Vinay, Dr. Savik, Dr. Santanu, Professor Sunil Singh, all the respected directors of CSIR, my HOD colleagues from CSIR headquarters. Incidentally, this study, the genesis, started from Goa itself. When we see that many of the people, especially the directors, have joined later in that period, that in 2020, in February 2020, Professor Sunil Singh had organized director conference at NIO Goa. And here, the first discussion on COVID-19 happened in the director conference. Many of people were thinking, some of the experts were also thinking that the virus may not be very dangerous in India. It will die in the high temperature and humid condition of India. But it did not happen. And we thought that what we can do. So initial discussion took place in the director conference. That was in the February 2020. And then when the incidents started coming in India, from 28th March 2020, we started our CSIR strategy group. That was a group that was chaired by Dr. Ram Viskarma, and DG CSIR, Dr. Shekhar Mande was also member, Dr. Anurag, Dr. Rakesh Mishra, and so many directors were members, and so many HODs from headquarters were members. I was the coordinator for that CSG, and all along we did around 300 meetings, and all the meetings have been recorded, and we have the minutes of meeting of all the 300 meetings. So during the initial phases, we were discussing really how to go about it, what CSIR can do, how we can support our fellow countrymen through our efforts. Then it started with a small thing like providing hand wash, and then mask, PPE. Slowly and slowly we supported, but then we realized that we need to study the virus. Incidentally, the CCMB was one of the first laboratory along with the NIB which cultured the virus in the country, and we were ready in that time. And in fact, we were in discussion with Bharat Biotech for giving the strain to them. So during that time, during those discussions, we supported, my division, my directorate supported around 54 projects on the COVID-19. And one of the projects on the suggestion of Dr. Anurag and Dr. Santanu was that we should measure the antibody response of our selected cohort. So in the first cohort vision started for the COVID-19, and all across the antibody response from the natural infection as well as the time progress through vaccine, both were monitored. Incidentally, I was one of the person having very high antibody titer. So we started with measuring the antibody titer. Genomics, CSIR lab was most prominent in providing all the genomics data to DBT, program, CCMB and IGIB were the leaders in that field. And all this study really formed the basis that we should go ahead and form our CSIR cohort, which is somewhere some permanency there. Permanency in the sense that in the many of the study, the patient or healthy volunteers drop out. So it was decided that if the CSIR regular employees, their family, the pensioners, or the volunteers, then the dropout and attrition will be very less. So this project was formulated in around 2022, and the vision was that not only the COVID, but other disease like cardiovascular, diabetes, even simply the BMI, that all the data were based on the study done on the Caucasian population. None of the data is based on Indian condition. As our previous speakers spoke about the variation in the body index, in the height, obesity, food habits, so many difference is there between Caucasian population and Indian population. And so many studies have been done from CCMB on this human population. So we need our data. And then we have started, we supported, even there are, this project is around 98 point something crore. And many people wonder because there is some procedural difficulty start after 100 crore. And many were thinking that it was designed how you could get it approved 98.9 or something crore, because this is, you have just avoided that one. But anyhow, everyone was very supportive, and we supported this project to IGIB and all the laboratory. I think nearly 1 year took in all the planning part, and now the sampling started, and we have achieved 10,000 sampling. The focus, as Dr. Santanu will explain, is on the cardiovascular, but I feel that you are collecting data on blood sugar, HbA1c. So this data can also be analyzed for the prevalence of diabetes, at least type 2 diabetes in the country. And really, what is the cutoff for Indian population? Whether it is 100 or 120, what is the really? Even I request IGIB team to come out for some study on diabetes also. If not feasible in this study, at least the data should be preserved, that if someone in future want to do it, can easily analyze the data and come out some recommendation for the diabetes also. So in a sense, the starting was based on our response to COVID-19, but we have gone ahead and we have supported this, and now microbiome of 6,000 samples is also being planned, and that will be executed. So we will get some more data also. So that was all what I wanted to explain about the Genesis. Thank you.
Thank you, sir, for highlighting how Phenome India was conceived and its relevance. We will now have a talk on importance of longitudinal cohorts by Dr. Vinay Nandikuri, Healthcare Team Director. Over to you, sir.
Thank you. To all the dignitaries on the dais and off the dais, it's a pretty big number out here, and the heads, colleagues, students. It's great to see such a gathering, and for unboxing of this Phenome India cohort. 10,000 seems like a large number, but if you realistically compare with many other things, this is a start. And I believe more such cohorts have to be done in our country to realistically get a very clear idea on what our own standards are, whether it is for diabetes or for hypertension or any of these diseases, because CSIR has a similar kind of a thing with respect to food size, which is a study done by CLRI. We should ultimately make our own standards for all the health parameters, because we are not exactly the same as the population that is there in the West. And in that context, Phenome India, I believe, is one of the first initiatives of its kind in India. And it's most probably my opinion, it is the starting point. And I'm glad that we have completed actually 10,000, collecting the data for 10,000 various CSIR individuals. The best part of this is the spread that we have across India, geographically, gender, age, superannuated to younger people, and various health conditions. Some people already have hypertension, some didn't even know they had. They got to know because of Phenome India. Same goes for diabetes. Some of the people, when they actually went for these checkups, they got to know that they are actually diabetic. So this has already in that sense served a kind of a purpose of making people aware that they should be monitoring their health parameters regularly. The other thing that, in this, the major unsung heroes, we don't talk much about is like the participation and the contribution of the students who are involved in this effort. Phenomenal. Because I had actually, when the camp was getting done, being done in IICT CCMB, at that point of time, I used to see the students actually being there from morning 7 o'clock and doing taking care of collecting all the samples and all for all the people who are coming in. And they were doing it for days together. And it's phenomenal effort and a lot of dedication I have seen there. Congratulations to all of you for doing a fantastic job of doing this. These cohorts, I'm really hoping that eventually we will allow us to have certain data on, one, of course, we will get a data on, because of the age groups and gender and other things that we have, most probably we'll be able to come up with some correlations on various health parameters, whether it is liver diseases or heart diseases. Hopefully we'll have some parameters that we can actually come out with. But I continue to believe that, CSR, while it is a good starting point, our population is one kind of a population. These kind of studies should be actually extended to non-CSIR and other participants, which is not necessarily our effort, but we are going to show the way towards that. And in that context, this study is all the more important, because once these findings are out, then we will have something to talk about, and other funding agencies as well as the government would actually realize the importance of these studies in the context of human health in India and otherwise. So this actually may change in the way the government looks at it in terms of funding to everything. To fund these kind of projects, it's not simply an easy thing. 100 crores is a big number. And if you add few other things, if you add genomics, that will easily cross something like another 20-30 crores. So it's basically a pretty money-intensive program to do this kind of work. But the data that we get out of such things is likely to be very, very valuable. And I basically congratulate the team led by Shantanu and all the other scientists in various institutes for doing this. And I know that people are going all around India and their students are going all around India. Congratulations to all of you and thank you. I'm glad to be here.
Thank you, sir, for sharing your thoughts on the future of Phenome India. I now request the dignitaries to kindly be seated downstage, please. Thank you, sirs. It's a happy occasion for all of us as the cohort has completed a milestone and the first phase of the project culminates at NIO. On this occasion, we have our dynamic leader and mentor, the Director General CSIR, Dr. Kalai Selvi, who has taken time from a hectic schedule to share her thoughts on Phenome India, which will be screened now.
Namaskar, Vanakkam, and pleasant morning to every one of you. I'm very happy to be a part of Phenome India project, which is recently initiated by CSIR to benefit basically the CSIR employees, including pensioners and their family, in terms of healthcare, which in turn will be made as a complete program covering the nation's requirement. When a country like India is coming out with a kind of an announcement during the G20, we consider, we believe, and also we recommended that the entire world is one family. We have to follow it in letter and spirit, and the country is following it up. And as a part of the country's very important publicly funded research organization, we from CSIR, we also take care of the points which ought to be considered with importance from the healthcare point of the country for its entire population. To start with, this study will have coverage with respect to all the 37 laboratories within the premises, or I would say within the umbrella of CSIR. And this project got initiated in the year 2023. So we are coming up with a series of tests by means of which we'll be able to first collect, then compare, integrate, and correlate parameters in terms of multimodal and multi-omics parameters in the form of a data sheet. And we have been successful in collecting this data from our own CSIR family members. And to our surprise, the response was overwhelming. Whether it is liver function or lungs related function or skin care related tests or gut microbiome related understanding, apart from the routine tests like the way we do in any other testing laboratory, series of tests were taken and a special focus is given to parameters like lungs, liver, heart, meaning is cardiology in the form of ECG, and gut microbiome also, and with the special relevance to skin care. And I really appreciate the team because they started with a questionnaire. They asked the individuals to fill the questionnaire wherein the lifestyle related parameters are already taken care of. And then they really go with the data. After the data is collected, then it is compiled, integrated, and it will be correlated from the CSIR viewpoint with respect to different states, different regions, their food habits, and their lifestyle parameters. I think this kind of an initiative will give an overall idea to CSIR to come up with the parameters with respect to Indian standards. And I have been told, and I'm given to an understanding that whatever medical parameters, the basic parameters that we follow in the country, today we do not have anything which is customized for Indian condition and for Indian population. Though our food habits, lifestyle, the climate, the weather condition, and the regio-specific arrangements and the structural arrangements are not having complete similarity with the other parts of the world, meaning is elsewhere in this world, but we still follow the standards which are being recommended and prescribed by other countries. Therefore, it was felt very much essential, and CSIR, from our own point of view, we understood the importance of such kind of parameters with their Indian values, and therefore this initiative has been made by CSIR with a special relevance to the laboratory called IGIB from New Delhi, which who is known for their strength in genomics related R&D. Along with IGIB, I should make a very special mention, Dr. Shantanu and his team, along with the director, the dynamic director, Dr. Saikat Maiti, the team, they have created a bigger structure by taking the help from research scholars and volunteered scientists and the experts in the form of their own working group from IGIB and from similarly placed laboratories who are having R&D focus in this area. And this team has been traveling to different parts of the country, and they are now able to come up with a kind of the completion of collection of more than 10,000 data. And I was told that initially they were expecting around 500 to 600 samples only for gut microbiome analysis, but it is too much overwhelming that they got around 6,000 samples, closer to 6,000 samples for gut microbiome itself. Therefore, without disappointing anyone, any CSIR family member for their curiosity, we thought that even gut microbiome analysis itself will be taken as an exclusive study, as an offshoot of this particular first phase of this initiative. And I've been told that this is a pan-CSIR, one CSIR program. This will be carried out at 3 spells, 3 times, and this will be going ahead for about a period of 5 years. So 2023 it started, therefore it will be going for next 5 years. And CSIR family members will be undergoing this study, cohort study. And I wish every success for this cohort study. I appreciate, congratulate, and I wish them all success, not only to the core team, but also to the extended team, because there's a huge number of scholars as well as scientists, apart from the leaders in the form of directors of few laboratories, are involved in this very important exercise. I congratulate each and every one of you, and the support from CSIR headquarters will always be there, because the ultimate aim is to ensure that we should have a very perfect, very precision, predictive, and also personalized medicine that should be made possible in the country. So we can call it as 4PM, and therefore this 4PM will become a reality through this cohort study, and my best wishes are always there. Thank you very much. Namaskar.
Thank you, Madam, for your good wishes. We are privileged to listen to your thoughts on Phenome India. I now invite Health Team Director, Dr. Vinay Nandikuri, for Phenome India Unboxing 1.0.
We have now collected 10,000 participants in the first round of Phenome India. Let us hear from the 10,000 participant.
I feel very happy to take part in this CSIR Health Cohort Knowledge Base program. I felt that this has got great potential for diagnosis and cure of various ailments of the Indian people of the Indian subcontinent. At the same time, this may help to diagnose something disease which is not normally tested over here.
With the sample collection complete, we now have a box of data to unbox, awaiting new insights.
Hearty congratulations. We will now have the overview of the project. I request Dr. Partha Chakrabarti, Senior Principal Scientist from IICB, to brief on Phenome India CSIR Health Cohort Knowledge Base.
Okay, so very good afternoon, and I'm really privileged to stand in front of you, this great team of leaders and colleagues and the students, to give you an overview of this ongoing project. Interestingly, a large part of the overview has already been covered, so I'll just try to connect the dots. And so as I'll start with this slide, some of you might remember, we have been using this slide for our awareness program at different CSIR institutes across the country, and we always start with this particular slide. So this is one of our favorite slides, so I kept it there. Okay, so to begin with, as it has already been discussed, that the requirement of a cohort, which has to be a group of people as it is defined, with the shared characteristics for a period of time. And as we know, we need it at India because if you see in the Asian countries, we only have for Japan, China, and Korea, and Taiwan, and there is no presence of India whatsoever in this biobank scenario in the global scale. And the rest of them are mostly US or Western European countries. So here, what we'll get at least 3 types of information. To begin with, we'll get an estimate of burden of disease for both communicable and non-communicable, the way the study has been designed. We would be able to identify a whole bunch of risk factors associated with the particular outcome. And also, we might be able to develop some risk prediction tools which will enable us for precision health and which will be specific for the Indian population. Now, as Dr. R.P. Singh has alluded to the history or genesis of this project, now I would just like to add one more point, that we have been thinking of developing a CSIR-based cohort even before the COVID came. We have been talking, I was a junior scientist at the time, I was talking to the others, the leaders, that if we could do that. And so it started, I think, if I remember correctly, 2017, 18, something like that. We're starting to formulate project, how to write about it. And in the meantime, this thing came up, COVID-19, and with the headquarters support and encouragement, this project, the cohort project actually started with the COVID-19 work. And as you can see here, as Dr. R.P. Singh mentioned, that over the period of time, we were able to show that how the antibody titer went up in the CSIR employees. And it was also shown that almost 20 to 30% of this, there is a loss in the ability to neutralize the virus within 6 months. That tells you the person might get a reinfection, and that exactly happened when the Delta came up. And it was also shown that a particular antibody titer is required for preventing the reinfection. So Delta came, and it showed that almost 27% people got infected again. And finally, the vaccine part, so the Covishield actually gave 70% protection. So this work has been going on. Once the COVID pandemic is over, we thought to come back with our original idea of developing this cohort. And what we have learned during the COVID period, that we already have a pan-India cohort in place, because through the COVID sampling. We already developed the network. We have a high participation rate, even during COVID time where nobody was able to move. And finally, we have developed an excellent in-house capacity to embark on this new project. And with this background, it was started, and the idea, so the long-term goal of this project becomes to develop a clinically useful personalized risk prediction scores for both communicable and non-communicable disorders, with a particular focus on cardiometabolic disease, in which we would include mostly cardiometabolic disease, and I'll show you the diseases which we mean by cardiometabolic disorders. In addition, we have a whole bunch of sub-projects or sub-objectives that would also include the seroprevalence and stability of SARS-CoV-2 antibodies, which will go on in this population, and for example, micronutrient deficiency, plasma metal levels, immunometabolic wellness, dietary influence, the microRNA markers, telomere length, all the biochemistry, metabolomics, anthropometric parameters, disease and pathway-specific MRM panels through proteomic study, the lung function, and all sorts of cooperation association, and eventually conducting symposium workshops for training students in various aspects of this omics research and other aspects of cohort studies. Now, as you know, so for execution of this project, we have divided our entire CSIR lab into 4 zones, east, west, north, and south. And we targeted, again, this is an old slide, this is our target, where we plan to have 10,000 samples, where all basic biochemistry and scanning, body scanning will be done. Eventually, through a process called reductional sampling, a deep phenotyping will be done in 5,000, and very deep phenotyping will be done on 500 samples, and that includes microbiome. So we, as already been discussed, that we thought there will be maximum 500 samples we might get. Now we have reached almost 6,000. So this one will move to here most likely, and CSIR headquarters will be generously funding this project in next couple of years. So the methodology, as you know, all of you have, I think, went through this process. So we did an online registration through our portal. Then there is sample collection, and on the sample collection day, we have both blood collection as well as body scanning. All the data are barcoded, these samples, when for molecular analysis or to biorepository at IGIB. And finally, after all the analysis, this data analysis will be done, and data will be deposited in a secured place in IGIB and for PI. So as you know, we all went through these 5 kind of body scanning tests, starting from body composition analysis, where we get all the details of our fat mass, muscle mass, bone mass, etc. In addition, we had a parameter of balance. If you remember, those who had some knee issues or osteoarthritis, they had issues with the balance also. So we had heart ECG, we have liver fibroscan, lung test, we have 2. One is spirometry and oscillometry, and finally we had a dermatological assessment. So all this body scanning was done. Later on, and later on, after body scanning is done, blood sample was taken. A panel of blood biochemistry was performed, starting from lipid profile to liver function to kidney function, cardiac markers, diabetes marker, hemogram, electrolytes, thyroid panel, few vitamins, and also markers for iron deficiency. After these are done, and you might have received a report like this from our partner Healthian, where you also get an AI-generated health score, somewhat like this. And after all this done, now the next R&D work are now in full swing. As you can imagine, we have 10,000 samples, all has to be allocated. It should go for different tests at different laboratories, and that's a huge task, and it's very meticulously is being now conducted. And in the R&D component, we have genomics, we have proteomics and metabolomics, we have immunophenotyping, circulating mRNA, metabolomics, telomere length measurements, and gut microbiome study. And as you can see here, a whole bunch of CSIR laboratories are involved in different components to go through all these R&D activities. And finally, so the last thing about this that we have been talking about, this 10,000 as we have proposed, we have reached it. And one of our colleagues has made this, I don't know, this image in our group. I put it, so this is a wonderful moment that what we have promised, we have delivered to some extent at this point. And thank you for your patience listening.
Thank you, Dr. Chakrabarti, for presenting the details of Phenome India. I now invite Dr. Rakesh Sharma, Chief Scientist from IGIB, to enlighten us on gut microbiology.
Good afternoon, everyone. I'll be giving you a brief overview on gut microbiome activity in the Cohort project. Gut microbiome is a collection of all the microorganisms which reside in our gastrointestinal tract, and they play important role in various functions. Some of them are digestion, development of immunity, protection against pathogens. And this gut microbiome actually is influenced by various factors. Major factors out of these is ethnicity, our diet habits, and our lifestyle habits, like physical activities and other lifestyle. Okay. So today, probably all of us know that gut microbiome is very important for our health, and any dysbiosis in gut microbiome result into or implicated into various health issues or disorders, specifically metabolic disorders like obesity, type 2 diabetes, cardiometabolic disorders, neurological disorders, and many of the intestinal diseases like IBD, diarrhea, Crohn's disease, and autoimmune diseases. So, gut microbiome studies in India are very limited, and they have been carried out in disease-specific manner and on very small sample size. So, the large studies and specifically on cohort kind of studies on gut microbiome are missing, and that is why we thought initially when the cohort study was being planned that we will like to do gut microbiome analysis in the cohort samples. So initially we were planning on 16S based amplicon sequencing for the samples, and the sample size decided was 500 samples because most of us were thinking that participants will be reluctant to give the stool samples for the study. So initially 7 laboratories which had the microbiology facilities, they agreed to participate in the gut microbiome component, and the initial sample size was 500 and in the 3 time points. So total samples were about 1500. So to encourage participants to give sampling for gut microbiome, we designed awareness pamphlets in English as well as in Hindi and distributed it to all the participants for their awareness on the gut microbiome importance. And then we also thought of making a pamphlet for sample collection procedure, because India is very different in comparison to all the Western countries when we think of these kind of issues, specifically like keeping the sample at home, where will they discard? So we used to discuss a lot on when people will collect samples, how they will dispose of the leftover stool, because we don't like to keep it inside the house, then somebody has to go out. Then we found these fecal catchers, and that can be disposed of into the toilet itself. So that we selected, and based on that we made protocols and distributed these protocols for the sample collection kit. And then we also built a questionnaire for the specific questions related to gut microbiome, which will be used for analysis of the gut microbiome data. Then when the sample collection started in December 2023 at CSIR-IGIB, when the people, participants were filling the questionnaire and selecting the time slots, we found that a large number of participants were interested in giving stool sample, and from there we found that about 50 to 60% of the participants were interested. Then Dr. Shantanu and me approached our director that can we increase the number, will there be some support for financial support for doing that, and he readily agreed. And then we started collection of all the willing participants who are willing to give these stool samples. And this number kept on increasing, and today we have reached more than 6,000 samples. So now and we also decided that we will be doing the DNA isolation at the site, and we have been able to do the DNA isolation of all the samples. Another aliquot has been stored for long-term storage. And then we also, in between, we also decided to change the strategy because of calculating the cost for these many numbers. And then we decided to go for shotgun sequencing so that we can get complete comprehensive data for the gut microbiome. And we have already sequenced 440 samples, generating more than 5,000 GB data. These are being analyzed. We plan to generate gut microbiome report for all the participants. We have already made about 150 reports, and they will be dispatched soon. This is basically for IGIB and CRRI, where sampling happened in between first. And then once this, we are hopeful that we will get some more financial support for the sequencing of these samples, and we plan to then do sequencing in next 3 to 4 months, or complete all the sequencing. And after that, we wish to generate the gut metagenome sample genomes and a population scale analysis with respect to all the metabolic parameter and lifestyle parameters which we have collected in the questionnaire and our cohort analysis. So we expect that we will be generating for the first time the complete gut microbiome diversity of Indian population, define the healthy gut microbiome. We will be able to understand the impact of different lifestyle and dietary factors on the gut microbiome. We will have a reference database for Indian gut metagenomes and microbiome. And in this, we are already in process of making this pipeline for directly getting from the sequence to the report. We are making this pipeline of analysis, and that will be ready very soon. With this, I will like to thank all the coordinator and investigators of the cohort project, and specifically I will like to thank the PhD and project students who were really putting all their efforts in making this activity as a success. My PhD student Vikas, who was all these last 6 months was busy in getting things and shipping to different labs where sampling was happening, and all the students from different laboratories, IGIB, NCL, NIST, IMTech, then NIST, Trivandrum, and CFTRI. With this, I will like to thank you.
Thank you, Dr. Sharma, for elaborating on the gut microbiome study. One of the most important and crucial aspects of a project is its data. We have Dr. Viren Sardana, Principal Scientist, IGIB, who will speak on the first glimpses of the data.
So good evening, everyone, and thanking you all amongst the dignitaries and this auspicious gathering for giving us a chance to present the initial glimpses of the data. And as Rakesh ended, so I'll just start from one of the calls I got from a participant. So as a clinical investigator, I was responsible to attend calls from the participants who had doubts. So I got a call on that कि डॉक्टर साहब मैं सिर्फ गट का सैंपल दे दूं चलेगा? मैंने कहा नहीं, ब्लड सैंपल कंपलसरी है, पर तुम बिकॉज द ब्लड पार्ट वाज कंपलसरी, सो आई सेड कि नहीं सिर्फ गट का सैंपल नहीं दे सकते, ब्लड भी देना है. तो आई सेड बट व्हाई यू वांट टू गिव ओनली गट सैंपल? नहीं कहते गट में कोई दर्द नहीं होता, ब्लड में दर्द होता है, इसलिए सिर्फ गट ले लीजिए, चलेगा क्या? तो मैंने कहा नहीं, यू है. सो वी हैड दिस डिसाइडेड ऑल दैट वी विल मेक एवरीथिंग वॉलंटरी एंड बाय चॉइस except the blood part, so as to run the cohort as a base. So moving on to the, so this is a slide, as Partha said, we use this slide to basically give the data glimpses and all. And I'll be going, before we go to the data which we have got, just as a disclaimer that these are just the initial insights which have come. Most of it has been QC'd, but there would be a lot of QCs which have to be done before we finally release the data. So where Partha ended, these were the basic objectives of the Phenome India study, and one of the aspects was to understand the data and to bring insights for India-specific data and to make it utilizable for development of future diagnostics or computational tools and clinical usability. So going ahead, some of the larger studies of the kind, and like Partha showed that apart from what blood and the R&D and molecular assays which we were doing a lot of scanning modalities and function testing for basically liver, lung function testing. Then we were doing, for lung function, we were doing both spiro and oscillometry and body composition analysis. And as you see, in 2024, we had one of the larger studies from India, which was based from ILBS in Delhi. Delhi multiple regions were used as study sites. And this had 6,000 participants, nearly 6,000 participants. While a study came from Romania, which was a retrospective study and collected data retrospective from one clinic over 12 years and presented that data as 23,000 fibroscans done. Then coming to oscillometry, and we have a lecture by Dr. Anurag today, so he will shed more light on the aspects of lung function testing, and he can tell more about what data scales we are talking about here. So oscillometry, you can see 1497, this was IGIB study, then there was a 323 study, out of which useful data was 253, published 2020, Bhopal, and this was oscillometry device, 11,560 Australian lead study. Skin profiling, we just have a major study done for 700 participants using the same instrument which we have utilized in this study, and the largest number we see is nearly 700 to 1,000. Now coming to Phenome India nutshell. Now here you will be happy to know what numbers we reached overall in this study. We understand, as Dr. R.P. Singh said, that 10,000 may not be a real number to represent India and the population in itself, but as a step, it is a significant number what we have reached, and many of these stand today as the largest studies in the country. Once they are published, they will regain that recognition. So yesterday we completed NIO. We have 1,269 samples, blood samples, out of which some will go for QC, and we may lead to a bit loss here, around 2%, but this will remain above 10,000. So these are zonal numbers, 3074 north zone, then west zone 2026, south 2920, and east zone 2249. We have body composition analysis available for nearly now 8,500 samples. We have spirometry available for 8,200 volunteers, and spirometry, mind you, many of you may have undergone. It's not an easy test to perform. So out of this, valid spirometries which we have which we have done QC till yesterday is around 6,500. Oscillometry, 7,000 we have done, combining both the types of machine, Resman Pro and TremoFlow. And we have FibroScan reaching 9,900. This will be the largest study which will be multi-centric throughout pan country. ECG, we have crossed 10,000, but mind it, this is not an ECG what we are talking about here. If you have undergone this test during this study, it was not just the ECG which was given to you, it was a 2-minute long ECG recording, and we have other investigators, Dr. Kumar and others, who are investigating the HRV responses in this. So it's a 2-minute long ECG record for HRV, which is the heart rate variability analysis. And this again also becomes a large physiological study for this sort of a database. Skin profiling, now I can say that confidently it should become one of the largest studies. Vamsi maybe can elaborate later on, but this is 700 to 1,000 what I have heard, and not, but what we have reached nearly is 9,900 overall with the same instrument pan country. Gut microbiome, I wrote 5,000 plus on a conservative side, Rakesh, but now I will change it to 6,000. So this is the overall brief nutshell data. So this zonal distribution was more of a logistic attachment that because we had different zonal labs, IICB, CCMB, NIST, IMMT, NIST, Jorahat, NCL Pune, who were coordinating all the logistics being held by other labs nearby. So we made these labs into 4 zones for that logistics aspect. So when we talk of these zones, the data has been analyzed initially zone-wise, but it may not be the true country-wise zone representation except the west. Rest is more or less okay. South, east, north. The west is typically west, central, and west. And here I have moved gut microbiome. So Partha, I have corrected this slide. So gut microbiome now goes into the 5,000 and a higher sampling thing. So this is the gender male and female split. Basically we had 43% females. This data comes till 9,600 before NIO collection. Major part of the data being represented is before NIO because NIO data is still undergoing QC and all. So this is 43% are females, 57% males. With this as the median distribution chart for male and females, and age coming to male 51, female to 49. The larger part contributed by the employees, which is around 4,600, 597 to be precise. Then their spouses. We had a major contribution from pensioners, which is 1,598, and their spouses. So we've got around 27% data from the pensioner population, which is in itself a good significant number to have in this sort of a study. Now this is a thing which is under process right now, so I will keep my comments reserved here, and both for this and the next slide, but this is an important slide and we would like to have later on views. We can have discussion today evening, and maybe the labs can start their own sub-projects or specific projects on the next 2 slides which we show. Important considering we have this data is 9,546, 7,000 people being unaware whether they have diabetes or they don't know the status. Out of which we got that, okay, 4,449 out of these 7,004 passed the non-diabetic criteria on both standards of ADA. And both standards of ADA implied HbA1c and fasting blood sugars. So whereas on both the criteria of pre-diabetic, we got 11% population who is not aware whether they are pre-diabetic. 2.8% population is not aware that they are actually diabetic on both the criteria. and 28% are in a state of hyperglycemia, means either of the combinations is higher or lower, and also the hyperglycemic stratification majorly makes the HbA1c, a large part of them is actually having high HbA1c, which they should be made aware of, and we actually made people aware of when they called us that, okay, what next steps I need to undertake. This is again the hypertension part, and in hypertension we had 9,000 verified data, out of which 5,774 were not aware that, but hypertension we would like to mention a quote unquote phenomena here, that we actually did just a one-time record during the sample collection. So we can have a planning, a better planning next time for a proper assessment of hypertension status as per the criteria, but this is what, and this is really called the tip of the iceberg, which is important to assess specifically in young population, that we need to assess these are the people who are not aware of their hypertension status. So roughly we had 848 and around 50 to 60% population is not aware of their hypertension status, but these could have also readings which have been recorded because the participant was moving, but as per SOP they were to be rested for some time, but still this is the numbers we are getting. Then coming to one of the important aspects which this study takes upon, and that was the liver health assessment. Now India being poised to become the capital for fatty liver disease, especially considering the nutritional aspects, our food habits, our sleep habits, we actually saw that now this is the 9,239 data points after passing the quality control for FibroScan check on the LSM criteria. So LSM is liver stiffness measurement, which is assessed by this device, and it actually gives you a data how stiff your liver is becoming because of inflammation, and at certain stages it will actually fail to recover back. So liver is one of the organs which has a regenerative capacity. So we need to be important here is, now you see north zone had roughly, so in this zone, this 10 to 12 and greater to 12, it is actually fibrosis and cirrhosis respectively. Cirrhosis will not recover easily. And if you see north, they have 1, 2, 2, 2, 0.6, 1.8, 0.8, 1.6. So both male and females have a very high incidence of fibrosis and cirrhosis, while it is still lower numbers in the south and the western population, though the data needs to be segregated individual city-wise and have to be excluded for other comorbidities. So this is an overall data. We need to exclude data or need to present the data as per etiology causes, because high liver stiffness can be caused by multiple things, which some of them which may not require a lot of attention also. So important is this 6.5 to 10, which is 11, 13, 9.6, 9.5, 11.2, 10.1, and so 50% of this population, because this part of this FibroScan reading has a low AUROC curve, that is, it has not very good predictive powers for this range. It could go lower or higher in the next repeat reading. So, but still 50% will have a higher score. So roughly this population is also having liver fibrosis, and this has to be treated. So coming to liver fat assessment is usually done by an ultrasound finding also, which shows you fatty liver grade 1, 2, and 3. This is the next follow-up or the surrogate marker of FibroScan accepted by hepatology societies. And you could see we have, and recently AIMS and others which published the large scale studies of FibroScan with around 1,000 data points, roughly 900 something. They said it is that Delhi has around 57% prevalence of fatty liver disease. Here you see, just jump it around 23, 29, 15, 52, 67% males in Delhi or North India, 33, 56 females, and similarly 56 and again 60. So we have roughly 56 to 60% prevalence of fatty liver disease based upon FibroScan readings, and these needs to be assessed or treated in time in order to have a better outcome, because it can actually revert back. We have people who have contacted us who got higher readings at the initial phases of the data collection, And now they have consulted their hepatologist or whatever recommendation our team gave them, because we cannot give a clinical opinion. So they have sought to dietary changes, and many of us have called back that when do we get a repeat fibroscan done. So now that was a segregated data by all things. Now if you see, we have a lot of higher variations towards north and east, whereas south is okay, and north, east, west is reporting higher stiffness in higher ranges basically. So we need to also see here what is actually contributed by alcohol and what is not contributed by alcohol. So spirometry data analysis, we actually got that FVC, and we assessed the FVC, which is the forced vital capacity, which is important to assess restriction. In all, we got around from 8,200, we have a quality pass data of around 6,700. This will go a bit lower towards more with further stringent quality control. And we could see that again, south had a lower lung function than east and west on the forced vital capacity, which helps assess the basically the restrictions and other aspects of the lung function. So coming to oscillometry, we had data for around 3,000 participants by tremoflow device and another 4,000 by the different device. So we could assess that quality control was passed by 2,000 and respectively people in Rassmann probe for 3,000, 3,900. So if you see the resistance values, we could observe that the resistance in all the zones typically for the full airways was higher than expected. These are the reference values, and whereas the green ones are the observed values. So the resistance is the higher is the resistance, basically you are encompassing a decreased flow to the lungs because of an obstruction or restriction in the airway disease. Then this was Rassmann Pro, again the same phenomena was observed. X5 was elastance, and lower is the elastance, better is your, or the higher is the elastance, better is the result. Whereas you could see here that all the zones fairly represented okay. But when we come to city-specific analysis, that I will show you. This is again the real resistance of the small airway dysfunction. We had 4,000 data points for a Rassmann Pro device. Next. No. Yeah. So R5 minus R20 represents the obstruction or the resistance offered by the small airways. And this is where you could see that it is being reflected in all the zones that there was a higher resistance. And going ahead, next. So this is the Rassmann, same phenomena by Rassmann Pro, but this is not showing any major observation when you do a zone-wise analysis, though that we are seeing that yes, there is an airway inflammation present in all the zones. We are being exposed to some inflammation characteristics in our lungs despite our know-how that we are not aware of it. So this could be because of pollution aspects, this could be environmental, this could be subchronic inflammation. Next. Go back. Slides are jumping. Yeah, show this. Okay. So Delhi, when you see Delhi and Pune, you could differently see that if you understand R5 minus R20 analysis, which is the small airway dysfunction, we could clearly see that both for males and females, we had a higher resistance whereas compared to a cleaner city like Pune, we had a fairly lower values compared to what was expected. So both here are higher and here they are lower. So I think there is, so we will stop here, but not far than the less. So acknowledgement and all, there could not be less than anything, the major acknowledgement to all the volunteers, coordinators, directors, and the people who actually allowed us to do this study, and the people who participated in the study, because without them, we cannot have accomplished this. So a major thanks to all of them, and there is not one single person whom we cannot thank in this entire study. So thanking all, and these are the initial glimpses. We will shortly share the final results with you. We will be upcoming in next few months.
Thank you, Dr. Sardana, for delving on the data till date. It only shows the amount of efforts gone into Phenome India. We will now have Director IGIB on stage to say a few words to all of us.
I hope, we have given little bit glimpse about the project and what the outcome we are expecting in coming few years. So what we have decided that at least once in a year, we will meet here somewhere in CSIR Institute. Now onwards, basically all students and scientists, participants, they will present the data, scientific data as well as outcome. And most of us, as it is health related data, will be very curious to know what is the outcome. So that is one, event each and every year we are going to organize. Second, it is kind of appeal to all my fellow directors. As you have seen that, microbiome study that we have started with 500 sample. Again, that was for, 16S RNA sequencing, basically low resolution sequencing, and we have went to sequence 6,000 sample whole genome sequencing sample. So it's very costly, and we calculated when we decided we calculated the cost, and it was costing around 8 crores. And IGIB, we have taken decision that almost 5 crore we are spending from our LR, and 3 crore we got support from headquarters through DG madam. So next, another important thing which is coming out, if we can sequence few of individuals under this cohort, genome sequencing, that's what I mean. So, or at least 2,000 genome sequencing. The reason behind it, because, if we have all sorts of data along with genomics, proteomics data, we can correlate this health parameter with genomics knowledge. So that's the thing we are thinking. So in this respect, almost, I asked Vinay whether he will be interested to take it forward. He is ready and I am also ready. But the cost is going to be around 20 crore. So appeal is here is that, if we can contribute from our LR little bit towards this 20 crore, then we could take forward this genome sequencing maybe next year. So with this appeal, I will hand here. You can go back and think, and later on we can discuss whether it is feasible or not. But one appeal I have kept. You don't need to take decision right now, but next 1 year, if you can extend your support to do this kind of large-scale genome sequencing within the cohort, I think it will be helpful for the country in future. Thank you very much.
Thank you, sir. I hope your thoughts will materialize soon. A dedicated manpower is one of the factors that goes a long way in the success of a project. We will now have coordinator and student volunteer experiences. I call upon coordinator from CSIR-NIO, Dr. Kalpana Chodankar, to share your experience.
Respected dignitaries, students, and my dear colleagues, a very good afternoon to all of you. It was indeed a proud privilege to stand here as a coordinator of this amazing and phenomenal Phenome India CSIR cohort project. As a doctor of CSIR-NIO in year 2011, I observed a substantial rise in the number of cases of hypertension and diabetes. On speaking to my other colleagues of other CSIR labs, the scenario was very much similar. At that time, many questions came to my mind, and one amongst them was, what if all the data from all the CSIR labs will put together could come up with a great potential of coming up with a great cross-sectional study and results which could further guide us in prediction, prevention, and treatment. Today, I can see this happening in reality. Yes, it was something which looked difficult, but was very much doable and achievable after all the brainstorming sessions followed by meticulous planning and designing of a very smooth operation of this kind. I'm thankful to the core team of CSIR, IGIB, under the leadership of Dr. Shantanu, for all their guidance from time to time in conducting this program here at CSIR-NIO. It was a team effort and would like to acknowledge the hard work put in by all the volunteers. Students, for the first time I could see a blend of students not only from different departments but also from different CSIR labs working here together for a common goal. A big thank you to all the participants who participated in this program. Initially, I observed a lot of apprehension about the program, like why I have to answer so many questions. What will happen to this data? Where will it go, etc. But eventually, this apprehension were followed by appreciation to the efforts put in by the volunteers. A feeling of satisfaction could be seen on the face of the participants after completing all the tests successfully. In fact, we had a great support from our pensioners group in addition to the employees, so much so that few pensioners even volunteered in the camp. My sincere thanks to Director NIO for all his unconditional support. My thanks to my co-coordinator, Dr. Sameer Damre, all the HODs and the project leaders for sparing their students. I thank my dispensary staff, IT team, director's office, admin, accounts, PNR, canteen, guest house, housekeeping, security. Without all this, it was not possible to conduct this. It was all a team work. Thank you, one and all.
Thank you, Dr. Kalpana. Next, I call upon Dr. Suman Singh from CSIO, Chandigarh.
Yeah, good afternoon, everyone. First of all, thank you, IGIB team, for having this event at Goa, and thank you to Director NIO for hosting us. In the morning, I was told that I have to speak about coordinators' experience, and then I sort of reverse film came into flash in my mind. Initially, I was not in the part of this project. It was Dr. H.K. Sardana was the coordinator from CSIO, and then director called me after superannuation of Dr. Sardana that you will be the coordinator of this. I said, I don't know anything about Cohort. He said, don't worry, we are with you. So support from the director is a big thing to run any show, any project. So from there, my journey as a coordinator started. And the moment Shantanu sir used to say, Suman, तुम्हारे यहाँ sample collection होना है, I used to think in the back of my mind, let's postpone it, because I was not getting the courage to hold so many gatherings and do these sample collections, because I was not from this medical area. But the IGIB team, the way they have formulated the project, when I went through the proposal, even the minute things were taken care. And they were so supportive. The program was designed in such a way that they never made the coordinators or co-coordinators, PI students, to get disturbed at how this program will be done. Even if we are saying that we are not having append-off tubes, even it's a very small thing, they were saying that don't worry, we are there, we will support you anything, but only the thing, you have to convince your participants. So convincing the participants was a challenge, because most of the participants were thinking it is my project or our co-coordinator's project, so what we will get. They were saying, like, you will get publications. And I was wondering, like, okay, if I'm getting publication in N number of my name will be there, I will not be getting 90 or 100 in APRs. I used to laugh that it's not the matter that it's a project of mine, it's a project of CSIR. Then our director, Professor Shantanu, joined, and he was not knowing anything about Cohort. The moment I said, sir, this is a CSIR PAN project, he said, go ahead, you need anything, any support, I am there. So he understood the importance by the word itself, CSIR, PAN-CSIR project. So it's the feeling that CSIR, if comes together, we can do wonders. And as we proceeded during this sample collection, registrations, we were able to convince people, but not too many participants were coming. And I was like, CSIR ka naam to pakka kharab hone wala is baar. But as we proceeded for the registrations, we tried to convince the documents which were prepared by IGIB, we shared with them, we made them understand what is the use of this, this program. They said, what we will get, what is the objective behind this? So we used to tell that in medical reports, you get American Medical Associations. Here we want to see Indian Medical Association. Report should be like this, that we should have a reference in the Indian population reference. So we started the journey, and in the first day, second day, we were getting appropriate number of registrations, but then the participants became ambassadors themselves. The speed or the number of participants we were getting in the end, it was very supporting for us, as well as a motivating factor also. So it's all because of our volunteers. Students played a major role in this, because without student, even the PI, even the project coordinators, we are nothing. So it is the efforts of the students who had volunteered this activity, and the training which I must appreciate, the training which IGIB has given to their students. They were given all the liberty and freedom. That is the most important, that we don't think that students cannot take the decision. So the freedom and the flexibility the IGIB supervisors gave to their students, and of course we also provided this flexibility to the students. That was the major force or major appreciating word which made it successful. So thank you all, and once again I hope next year we will meet here, as sir said. Thank you.
Thank you, Dr. Suman. I now call upon Dr. Swati Saha, CMERI Durgapur, to say a few words.
Good afternoon to all, respected dignitaries, directors, HODs, students, and my dear colleagues. I am really very much privileged to be part of this project and to be here right now, so for the beautiful gathering. and for the unboxing Phenome India. So when I first came to know about this project, I am really very much impressed about the project proposal, and I am very much convinced about the project. So first time what I have done, I registered myself from CMRI end, so that I can make the people understand the importance. I can tell the people about the importance of that project. So as coordinator, I think there are so many coordinators present over here. They must agree with me that convincing people to enroll this project is very much difficult. So gradually, I have to talk to the participant, to talk to the patient whenever they used to enter my chamber for consultation, that you first register yourself. It's a very big project. You will get n numbers of reports within a span of 2 to 3 hours. And please register yourself. Initially, there were so much questions about that project, that what is the utility of this project, and we have so many impaneled hospital, we can go right there and we can do the test. Then what added things you can do? So I mentioned there are 2-3 tests that are important, like gut microbiomes, that skin analysis test, another is BCA. They are very new. So that is, these tests are not easily available in our setup in Durgapur. So gradually we planned, I talked to Dr. Sengupta, so we can plan this program in Durgapur in the first week of March. So quite a large number of people, they registered and came for the program. Almost 375 participants, they have registered, and every day, generally 8 to, we have started from 7 to 12, and by the 12:30, it will be over. So I must appreciate the students' effort. They have what Dr. Suman told, that students are really amazing. They are so well trained and well behaved, because in health professional, whenever you go to any hospital, you always think that the other person. Hello? Oh. The people who are sitting other side, they should be little bit compassionate. Their behavior, their talk, with their talk, we can feel good. So the students, they are very much, I think, in that sense, they are very good. And with their help, we completed the program. Our retired person, our employees, they are very much pleased with their program, and they are so professional. I must really appreciate their effort. I think they should we should give a big round of applause for them. And after that, the report comes, and being a medical professor, people used to come with all the reports, then we have to answer everything. And now the questions are coming when the gut report, the skin report, all will be coming. So I think that will come within 2-3 months, I hope. And that, I think it's a good project, and we'll be continuing for next 5-10 years. I don't know, Dr. Sengupta will tell how long we will continue, but one must think, add these things, that next time when we are going to take the sample, the number will be big. So from CMRI end, I think the number will be almost double or triple. The people are so much enthusiastic, and right now, some people, senior citizens, they used to come and tell me it should be continued for the months together, so that we can go for this test. So I think it's a good project, and we are very success. Thank you.
Thank you, Dr. Swati. Next, we have student volunteer, Ms. Vaishnavi from NCL, Pune.
Good afternoon to one and all present here. Thank you for giving me the opportunity to share my experiences. So in this project, I was a part of gut microbiome team where I gained invaluable experiences. So when we started the stool collection kit initially in NCL Pune, so participants were hesitant to give the stool sample. But once they got to know the importance of the study, so they enthusiastically took part in the study. And interestingly, later on, we got an overwhelming response. So this project has equipped me with a diverse skill set that extend beyond the laboratory skills. In this project, I got an opportunity to work on from its inception, like from indating to procuring and setting up equipment, and also to convince the participant to enroll for the study. This project provided me with an exceptional opportunity to develop a wide range of skills such as time management, dedication, patience, and communication skills. I am grateful for the opportunity to be part of such an innovative project and look forward to contributing further to it. Thank you.
Thank you, Vaishnavi. I call upon Ms. Dipshika, CCMB, Hyderabad, to share your experience.
Good afternoon. I'm Deepshika. I'm from CCMB. I was part of the South collection team. It was a very unique experience. We were learning about different equipments and also trying to handle participants on the same hand. It was also very intriguing to know about different kind of instruments and the tests that we perform, so that the outcome that we are getting from those tests could be used for the other scientific studies later on. Out of all of the labs that I've been to, NL was the non-biological lab. So the other biological labs that I have been to, they were asking questions about the parameters and other things. But in NAL, I was getting questions on technical stuff, that how probes work and how we measure the parameters using these probes. So that is the point where we all connect on different parameters, but the perception is the same for all of us. So as we all connect here, we were also having very interesting conversation with the participants there. So one of the participants, he was also asking about the skin analyzer equipment, where he was also suggesting that they could build a lower version of the skin analyzer equipment, which was cost effective. So that was also a very good conversation. It was also very interesting. So finally, I will end by congratulating all the PIs, coordinators, and also my fellow teammates on completing the first session of the sample collection in the Phenome India study. Thank you.
Thank you, Dipshika. To follow, we have Dr. Meghna from IGIB Delhi. Dr. Meghna.
Good evening, everyone. A small correction, I'm yet to give my Viva and being a doctor. So many of you might recall me as the person asking you to lift your shirts up and giving you shots with something looking like a gun. As some of you might have guessed, I was doing fibroscan for this project. I'll start my experience by saying that since the start of my PhD, I've always wanted to be part of such a project which involved cohort and a big interdisciplinary team, but it could not happen. So while I was quite sure of joining this project post my PhD, Dr. Shantanu was quite hesitant when I initially told him that I was interested in joining this project, since it was quite a different project than my PhD, and it involved working with instruments and traveling intensely across India. Not sure how he feels now about the same, but after traveling several cities and passing several months and a number of CSIR labs, I feel very privileged to be part of this project that has very high possibilities of bringing historic change in the country's health system. And it will be very useful for the generations to come. When I was first told that I'm going to handle fibroscan, I thought I could handle anything but this instrument. But later got so passionately involved that whenever someone used to enter my station, I used to feel that I won't let you go empty-handed. So I will give you a report. I will find your liver. What used to be the best part was innumerable blessings from the pensioners, happy smiling faces post-collection, appreciating our effort, intense discussions with our team for even making the process better for all of us. Extreme patience, staying calm with the participants, come what may, resilience, intense traveling, working in diverse environments, having their own pros and cons, working constructively with a big team of scientists and students, actively working on the criticisms and building up the positives. I can keep counting of what I've learned as a part of this project. Lastly, I'm extremely thankful to all the scientists, participants, students, volunteers, and everyone else who made this collection phase of this study success. I'm looking forward to the next part of this study, which is analyzing and interpretation of the collected data. Thank you so much.
Thank you, Meghna. Thank you to the coordinators and student volunteers for your feedback on the experiences. I now request Dr. Shantanu Sengupta, Chief Scientist, IGIB, and Project Investigator to deliver the vote of thanks.
Good evening, everybody. It is an honor for me to stand before you and propose the vote of thanks for this, this wonderful year, ultimately made with some success. So the outcome of a project usually depends on the attitude that we have before initiating the project. And I should tell you that a core team of scientists from 6 different CSIR laboratories spent hours planning for the project. And even before this, Chandak, I, Rakesh, from probably 2016, 17, we were discussing on what should be the theme of the project. Then Partho Dippaman came. Then others joined in, and the team spent several hours online. Courtesy COVID, we started learning how to interact online. So during COVID, this project, DG CSIR at that time said, can we use your cohort to understand the seroprevalence? The team took the challenge, and every week we used to meet online. I thank all of you for this. And the attitude not only of the core team, but the entire CSIR, starting from DG CSIR, I can't thank her enough. Unfortunately, she couldn't be here in person, but the enthusiasm she showed every time we went and talked to her about the project is amazing. And when on 6th of May, Shobik and I went and approached her that, Madam, we have got so many gut microbiome samples, can we have an offshoot project? Immediately she agreed. She immediately told, write down the project, I will fund the project. This will be an offshoot project. In the process, she also made me commit that the gut microbiome sequence should be completed by 26 September, and I put up the challenge to Rakesh for doing that. I'm thankful to all of you, all the directors of CSIR. Without your active support, collection, this amount of collection would never have been possible. Wherever I went, I had the privilege of traveling to all 37 labs of CSIR, and wherever I went, I saw the enthusiasm of the directors there, the coordinators, and we were pretty confident that, why 10,000? We could have done more. When we started, people said 10,000 people from CSIR. CSIR probably has only 40,000. Do you think 25% people will give sample? We were on a high after COVID, and we said yes. Confidently, the attitude was yes, we can get it. And today I can tell you, if you all would not have cooperated, the directors of the CSIR Institute, this would not have been possible. The coordinators, I can't I don't have words to express my gratitude to the coordinators. Whenever I called them, they responded. We gave numbers to coordinators that we want this many samples from your institute. Most of the time, they exceeded the request. Sometimes they came back and said, if more people participate, can we continue? I remember in Bangalore, the situation it was such that the coordinator asked me, should we stop the registration process? Because we could only collect 900 samples and 1200 registrations were there. Anyway, so coordinators did an amazing job. Each and every coordinator, they gave their heart out. Thank you. Thank you to all of the coordinators. And the students, I don't have to tell anything. All of you have seen the effort of the students. And believe me, none of these students had any background on doing the sample collection. They were very ably trained by Viren, Vamsi, from the medical clinic point of view. The instruments, they got certificate from the companies. And then there were people who taught them the behavioral aspect. Because they are going to travel all over the country. There are various kinds of people. Their behavior should be impeccable. And I have till now not got a single report that any one of the team misbehaved with anybody. So a great round of applause to the students. They have traveled, sometimes they have traveled 14 hours, 16 hours at a stretch. I remember from CCMB, they went to CFTRI. They started a bit late, but they reached CFTRI at 4 in the morning, starting 10 o'clock the previous day, 10 o'clock in the morning the previous day. Continuous stretch. Sometimes there was breakdown in the bus, they had to wait, but they were all patient. It's an immense effort of the students that we could achieve this. Hats off to them. I would fail in my duties if I would not thank our partner in this, the diagnostic partner, Healthians, in this project. They came through a competitive tender bid, but then, they could have told us, our job is just to collect the sample and give you the report, which they have done very nicely. Apart from that, lot of our different kind of requests, very smilingly they helped us in that. Be it, there are engineering labs who don't have biodisposal mechanism. So we requested them, they don't have a means to dispose. Can you help do it? They took that job, they did it. So a round of applause to them. Finally, for this day, I would sincerely thank Director NIO, coordinators, Kalpana, Samir, and the entire NIO team. Whatever we asked for, we probably got much more than that. Thank you to the NIO team. A wonderful effort. And as Shobik said, we will plan to do an annual event from next year on. So what we'll do is, we'll assign the job to one institute to conduct the Phenome India conference in Goa. Because this is the place where you can have good science as well as good food. So Ramanuj Narayan from IMMT will hold it in Goa. So thank you once again. Thank you all for coming. We'll again meet next year. We'll start the sample collection from January onwards. I would also like to thank the monitoring team. You know, this project will never remain on course unless it is monitored properly. There is a task force, there are external members, Rakesh Mishra, Anurag Agarwal, there is monitoring committee. Unfortunately, the chairman of the monitoring committee wanted to come, but somehow due to his personal commitments, he could not make it today. Nikhil Chandan, Dr. Madhu Dikshit, Suman Kundu, Director Bits Pilani, who is sitting here, Dr. Sangamitra Bandyopadhyay, Anurag, we are really grateful to you, and we would really request you to streamline the project. And finally, I would like to thank all heads of CSIR. That was very important. R.P. Singh ji, Vandana madam, regularly, Vandana madam told me one day that, this is the longest OM I have typed. 33 laboratories budget in one project was the longest she typed. What was interesting is, different labs have to buy the same equipment, but the money has gone to different labs. So CSIR purchase, they found an innovative method. They told, okay, let one institute tender it on behalf of 4 different institutes. It will be written in the tender, so you get a bulk discount, you get the same equipment for all, and in the tender it will be written that the purchase orders will be given by the respective institute and the material delivered to the respective institute. This kind of thing has never happened. The cooperation that we got from everybody, I'm telling you, Phenome India is lucky. Right from the students to the administration, everybody was so supportive. IGIB Finance, similarly Finance, Purchase Department, similarly I can tell CCMB, NCL, what we did was we asked NCL to process the equipment because NCL Purchase Division did it within 15 days. Hats off to their entire purchase and admin team. NIS Jorhat, I'm specially grateful to NIS Jorhat. Despite not having budget, they helped us procure the fibroscan as well as a mass spectrometer so that we can also use those samples. So, if I start thanking, it is going to take a long time. We are short of time. We have the popular lectures. I can go on and on, but I would like to end once again by thanking the students without whom this could never have been achieved. Thank you.
Thank you, Dr. Sengupta. We are much grateful to you for taking up the responsibility of leading Phenome India. All are invited to kindly join for refreshments outside the auditorium. There will be a group photograph outside the auditorium just before refreshments begin. After the tea break, kindly join for the interesting popular lectures. Thank you.
Hello. Dr. Reddy, can you confirm that you are online? Dr. Reddy, can you please confirm for the popular lecture, speaker 1?
A very good evening to one and all. Welcome back. We will now begin the session on popular lectures. The first speaker is Dr. Ankush Desai, Professor and Head, Department of Endocrinology, Goa Medical College, Bambolim, Goa, with an MD in Internal Medicine from Goa Medical College. He did his DM in Endocrinology and Metabolism from AIIMS, New Delhi. He has 25 years of experience in clinical medicine and published 40 research publications in peer-reviewed journals. He has been a principal investigator for 15 clinical trials and epidemiological studies. He was conferred Public Health Leader Fellowship, sponsored by NIH, USA, and conducted by Emory University's Rollins School of Public Health Foundation of India, and National Institute of Public Health of Mexico for the year 2013-14. Today, he will speak on diabetes mellitus in India, problem, status, and solution. Over to you, Doctor.
Good evening, everybody. At the outset, it is my sort of responsibility as the son of the soil of this place to welcome all delegates and sort of the dignitaries here to the land of Goa, the land of sun, sand, and sea, as we call it. I hope you enjoy the hospitality of this place and carry some pleasurable memories of this place. At the outset again, let me congratulate CSIR-IGIB for the Phenome India project. I heard about it just a couple of days ago, and it's a tremendous achievement, whatever you all have done, and I expect that the results in the coming months and years would really be shedding a lot of light on how we can look at metabolic disorders in this country. Someone who is in the field of endocrinology, which deals with metabolic disorders, for me, that's very, very interesting. Let's hope we can do something better here. If I have any role to play as part of the, as part of the faculty at the medical college, at Goa Medical College, I would be really happy to contribute. Again, at the outset, let me clarify this thing very clearly. I don't know whether people have seen Dr. Nikhil Tandon's photograph. I just heard my friend Praveen say to me that there was some video of Dr. Tandon. So I am representing Professor Nikhil Tandon here because Dr. Tandon could not come today and deliver this lecture. He is the chairman of the project monitoring committee. He is supposed to be actually delivering this lecture. Just a week ago, he said to me that, Ankush, I cannot come, and I really would appreciate if you could go ahead and give this lecture. And obviously, you cannot say no to your mentor, so you have to say, yes, sir, I will do it. I hope I can do a good job and sort of satisfy everyone here. It's a bit of this that, the hall is not very full. I assumed that, the hall would be packed with a lot of dignitaries and delegates, but let's hope that people can make it this. So this is, oh, okay, yeah. So what I was supposed to do, oh, these are my disclaimers, and there's no conflict of interest related to this talk. Yeah, I'm supposed to talk over the next 30 minutes on these 3 topics or subtopics. The first one is about the problem of diabetes in the country. This should interest the community at large. People all across the strata of society, they should be interested in this, whether you're a scientist, whether you are a patient with diabetes, or whether you are just anybody. It should interest you. Where do we stand as regards diabetes and metabolic disorders in this country? And there is some amount of hard data which has come in the last few years, which has just got published less than a year ago, and I would like to shed light on that so that you, so it's sort of an eye-opener to the community. The next part is what Dr. Sengupta wanted me to talk about. Dr. Sengupta wanted that I should talk about the management of diabetes, and so this will interest the individual in you, someone who has to deal with diabetes for himself or herself, or for members of the family? If you are taking care, like what is it? So I have tried to sort of give a general, in 10, 15 slides, how do you manage diabetes in sort of a lecture like this. I hope it is interesting for you all. The last part is I'm trying to sort of give what are the solutions to the big diabetic epidemic in this country. And this is what Sir Dr. Nikhil Tandon has also worked on, and I hope I can sort of represent this in the right manner. So the epidemiology of diabetes, so I put this slide which I had made some years ago, and this is most of the work which was done in this country till the year 2008, I guess. And so if you see in the last 50 years, there's been a lot of work on the epidemiology of diabetes that has been done. And almost 50 years ago, Professor Ahuja did work on, so these are studies which are sort of, big studies. We try to put up the big studies. There have been multiple studies done across different regions, different states, sort of, small populations, but we try to put up the big ones. Like if you see here, the sample size is pretty, one of the, the big ones in this country. And these were representing urban and rural parts of the country. And they were predominantly sort of national level studies. And from Ahuja's work in the year 1970s, you found that the prevalence rates was around 2% in urban areas and 1.5% in rural areas. Then Professor Ahuja did work another 2 decades later and showed that it has increased to almost 2% in rural areas and 4% in urban areas. So that is the prevalence of diabetes. And then it went on and went on and went, and somewhere here in 2006, Dr. Mohan, V. Mohan, I guess you people would be knowing, he did work at Chennai that is called the QR study, and he showed a prevalence almost like 15%. That was a big jump at that time. Like, people are not ready to believe, is it 15% in this country? And this was an urban study as well as rural work also was done, but this representation is only of the urban work. And then there was some more work which has been done, which has said, that if not 15%, somewhere around 7 to 8% is what we are looking at also. Now, we have to understand 2-3 more facts, that different people have used different age limits, they have used different criteria. Somewhere in the year 1997, the American Diabetes Association came up with its new criteria for the diagnosis of diabetes, and that is the one which is used currently. So, somewhere, so this is just to say the same thing, there's a secular trend which has been increasing. So somewhere around 2007, 2008, ICMR proposed that let's do a task force project on the prevalence of diabetes in the country, and let's look at the entire country together, once for all. Big country, it is not possible to do it in in 2 months or 3 months. And as you all have said about Phenome India, that it has taken such a lot of time to get the data of the 37 CSIR institutes. If you go to each and every state, get the investigators on board, get their approvals of their ethics committees, administrative approvals and everything, and then run the show. So it's taken a lot of time. And from 2008, I say, when the first work was started, and we completed some of the last work in the year 2019, 2020, and I just about completed the Union Territories of Lakshadweep, Daman, Diu, Dadra, Nagar Haveli 1 month ago, with data which is not yet analyzed or published, it's just being entered. So somewhere, country also has, sort of reorganization. This number would be 28 and 30 somewhere. So 28 states and union territories in the country. This is a cross-sectional study, one time, community-based survey of all adults above the age of 20 years. And the representative sample which was taken was around 4,000 individuals, 2,800 in the rural areas and 1,200 in the urban areas, and per state it was, and it was done in a phased manner, as I said. This is just to put the 5 phases in which it was done. In addition, there was a northeast phase. 1,13,000 odd individuals were screened. I can't get into the details of all this because it's going to take a lot of time. This is the methodology. Again, one slide I've tried to put across the methodology because I have done this work in Goa also, and I've done in the other parts of the country also. This work was predominantly an ICMR task force project which was run with the Madras Diabetes Research Foundation with Dr. Mohan, and we were partners in that work. So all the study subjects had one questionnaire to answer, which was a big sort of 30-odd page questionnaire. Then they had their height, weight, and waist circumference measured, blood pressure measuring, and we used capillary blood glucose in the fasting state, and after 2 hours of glucose load in people who were non-diabetics. So this was common to all the subjects which were enrolled. Every 5th subject was additionally gave a venous sample rather than the capillary additionally for lipids and creatinine. So that would give you some information about the dyslipidemia status in the country. A resting 12-lead ECG just one time, nothing more than that, and a dietary assessment questionnaire also. In addition, individuals who self-reported diabetes, those who self-reported diabetes, they had additional diabetes questionnaire and a fasting venous sample for a A1C to measure the degree of glycemic control. So this was how the study was planned and done, and so this is the sorry. So there is one slide which seems to be not showing. Yeah, there is one slide before this, which is the entire sort of, this is, if someone can help me out, means there is one slide before this one. Oops. No, sorry, go ahead, results. After this, it's not showing there. Yeah, that's the table of the entire thing, the prevalence. It's okay, I can still talk it out. So what I want to say is that, so this is the weighted prevalence of diabetes in the whole country. The overall prevalence is 11.4%. So currently we say 11% of the population of the country has diabetes, and this is both the rural and urban area, means all entire together. And this is for urban India and this is for rural. This is the color coding. Like so, the red one is like 10% or more prevalence, and green one is showing less than 5% prevalence. So except for Uttar Pradesh, which had, if I'm not mistaken, some 4.8% prevalence, rest all had more than 5% prevalence in this country. And the state which had the highest prevalence was Goa, with 26.4% prevalence of diabetes. And so you can see, if you see the metabolic map of India in terms of diabetes, the urban area, entire area of the country becomes into either 7.5 or more than 10%. In rural area, India is split slightly far behind, means behind, but not really far behind. So how does this go now? Oops. No. There are too many slides which have, one more slide which has gone. So is it not playing well? I can't understand. So there was another slide after this which is going to show about the pre-diabetes status in this country, and I'm sorry, I can't get the numbers now. 15% sort of was the prevalence of pre-diabetes. So how do we go about it? If we miss slides, then it won't function well. Okay, this is just to say, because I'm from Goa, and we are at Goa. So the prevalence of diabetes in Goa is around 26%, and you add to it another 20% of people with pre-diabetes, you get 46 or 47% of the population of the state is having, above the age of 20 years, is having some degree of dysglycemia. Means if this room had all people from Goa, then either the person who is talking or the person next to him has to have some degree of dysglycemia, and every fourth person would be having diabetes. So that's the sad state of the diabetes scenario in the state and in India. Oops. So this was hypertension, and the numbers are like alarming. 35% of the population is supposed to have hypertension right now from the ICMR-INDIAB data. Does it go? Okay. And abdominal obesity in almost 40%, and we'll not go into details of this. And so almost so if you see about 25%, so almost the entire country is having abdominal obesity. Oops. Okay, so there are no, the urban-rural differences which were seen at the time in the last 2-3 decades earlier is really dwindling, and we are finding that, between urban and rural areas, the differences are just not now being maintained. The age variation, we found that while we talked about diabetes in a way like, it would occur in the 4th, 5th decade onwards, now we are finding it in the 2nd and 3rd decade itself that diabetes is occurring. So what are the risk factors? So this is not the next few slides. This is exactly what was from ICMR-INDIAB. The next few slides is just to tell the information regarding what are the risk factors. And okay, so this is a slide which I've been using for most of the times. If people have seen me as a doctor here giving a lecture, this is a slide which I put across many times. This slide encompasses what is the problem for diabetes, pre-diabetes, hypertension, cardiovascular disease, hypercholesteremia, obesity, everything for this country. So you find that there's a lot of eating, there's a lot of sedentary lifestyle, stresses, a lot of urbanization. This results in people having obesity, and this is not no longer left in the cities. This is also seen in the villages where people consume a lot of burger and drink carbonated beverages, and this is also seen in the children. As a result, this slide in one go will tell you where the problem is. If we do not want to acknowledge it, then we are missing the bus. We are falling far behind. There are genetic factors. I know Dr. Bhardwaj at IGIB did a lot of genome-wide analysis studies on the role of genetic factors, SNPs, and the epigenetic factors. But beyond that, the predominant force driving the diabetes epidemic in the country right now is obesity. Okay, so yeah, so it is resultant from this. The additional point is that Indians tend to have more abdominal visceral adiposity rather than peripheral or generalized obesity. Oh my God, which slide was? Someone else is also moving it. I'm sorry, I can't. Yeah. Okay. No, it's okay. Okay, so this was to show a paper by again one of my mentors at Emory University, Professor Narayanan. So he showed that what is the relationship of obesity to development of diabetes. What is the lifetime risk of developing diabetes based on the baseline BMI and age. And if you see, so at 18 years, so this is BMI is like less than 18.5 is underweight. 18.5 to 25 for the white Caucasian is sort of normal weight, 25 to 30 is overweight, and this is the obese and the super obese, like, you know. So if you see, if at 18 years, if you have a BMI of 35, 18 years, there is almost 70% risk of development of diabetes for a male and another 75% for females. So it is at this age, at 45 years, this risk would be much lesser, like, you know, 62. Even the very high numbers still lesser. So if you end up with obesity at a very young age, the risk of development of diabetes is tremendously high. The same thing has been replicated in India by some of my colleagues, and they used for this the incident rates from the CARS cohort, which is again a surveillance cohort, and the mortality data from the government of India, and they used the ICMR INDIAB data for prevalence of diabetes, and they showed that at age 20 years, so unfortunately their analysis was done with BMI of less than 25, 25 to 30 and more than 30, but you miss the one small group. Two things you miss out. In Indians, these numbers of BMI are much different because you can't use these numbers for you know, defining overweight obesity for Indians. And second thing is they have clubbed normal weight and underweight as one group, which itself sort of sets in a bias. But still, at the age of 20 years, if your normal BMI of less than 25, you have a 40% risk here, lifetime risk for men, and 51% for women. And if you at 20 years, if you have a BMI more than 30, at 20 years, if you have a BMI more than 30, it's like 86, 87% risk of development of diabetes in men and the same amount in women. So that is means literally anyone and everyone who is having a BMI more than 30 at 20, 22, 24 years probably would end up becoming diabetes in the lifetime. There's one more slide which I did not put up, which was trying to show that, you know, actually how many number of years you would have without diabetes, and that would be a very small number. Okay, so that was about the problem of diabetes in the country, and I, in the last 10-15 minutes, I hope I have done justice to that. The next part is a sort of a general topic. The thing is about how do we manage diabetes. If people of you, some of you who have diabetes or who take care of individuals or, you know, home members with diabetes, and this would sort of interest you. So how do you screen? You screen with a fasting plasma glucose or a 2-hour OGTT or an HbA1c. One of these three tests you can do, and that would give you sufficient amount of information to classify a person as either diabetes, pre-diabetes, or normoglycemia, and these are the numbers. I don't want to rattle them out for you, but you can see anyone who has a fasting plasma glucose more than 126 milligrams per deciliter, or a 2-hour post-glucose load of more than 200 milligrams per deciliter, and A1C more than 6.5, more than equal to, would classify for diagnosis of diabetes. True, if you did not have symptoms, then we would expect you to repeat the how much is the relevance of this A1C in our settings. It depends on the methodology which is used for doing the HbA1c. So that part you have to be sure about. Okay, so why do we need to treat diabetes? Because it causes a lot of complications across the body. I don't want to get again into details of this. So, and we know that the major ones are the microvascular ones, retinopathy, chronic kidney disease, neuropathy, and the macrovascular ones, coronary artery disease, heart failure, peripheral arterial disease, and stroke. So, if you thought like diabetes was just, it causes hyperglycemia, no, it does cause complications. On its own, standalone, does type 2 diabetes really cause complaints or problems with hyperglycemia? Very less. Probably type 1 diabetes or severe insulin-dependent diabetes does cause. But when it does cause complication, it really results in a reduction in life. Okay, so and what has the evidence in the last say 30, 40 years which has been there is that if you drop the A1C by 1 percentage point, you can reduce lower extremity amputation by 43%. you can reduce all microvascular complications altogether by almost 37%, and you can reduce myocardial infarction by 14% or stroke by 12%. So that means, this is data from UKPDS. So it shows that in people with type 2 diabetes, if you actually control their blood sugars and get an A1C reduction of 1%, so someone was 9%, you get it down to 8%, or someone 8%, you get it down to 7%, then you get this much amount of benefits. So it is worth doing the efforts. But in today's world, the treatment of diabetes is not just glycemic control, and hence I have sort of tried to put down these 5 principles of management of diabetes. The broad principles are: you should attain and maintain ideal body weight, you should adopt healthy lifestyles, including diet, exercise, sleep, and mental well-being. The third one is, I talked about glycemic control, which has been the sole aim in diabetes control for most of the time. So that's not what. So today the American Diabetes Association looks at much more than this, and everyone believes that that's the way to do it. Achieve other metabolic disease control, like including hypertension and dyslipidemia, and there is evidence to suggest that. And then you need to screen, prevent, and treat the complications of diabetes. So this, if you can do, then this is sort of complete diabetes management. Yeah. So if you were a patient or someone of yours was a patient who's going to a physician, then please ensure that these baseline tests are done for you all, including a fasting blood sugar, a fasting plasma glucose, HbA1c, kidney functions, liver functions, counts, lipid profile, thyroid function, urine examination, including urine microalbumin and creatinine, ECG and ultrasound abdomen, and TB screening if it is diagnosed for the first time. So these, unfortunately, sometimes physicians forget to do this. So they would do, someone would do fasting plasma glucose and someone would do kidney function test, and it's very rare to find that no, they have actually done a urine microalbumin to see what was the rate of microalbumin at the outset, to see what was the evidence for the NAFLD at the outset. So this has to be done, and you have to enforce it with your physician. And this is what you need to do over time. So fasting plasma glucose and postprandial 1 to 3 monthly, in A1C every 3 monthly, and this set of investigations, the ones which I told about just now, including a fundus examination annually, and others screening as per the physician's discretion. So as a diabetic patient, someone has to see to it that so many of these things get covered. If you do not do this, then you are falling behind, and we might find that you have actually ended up with a complication before you are aware about it. Okay, so this was this, and I wanted to talk about CGM also, that but we'll just get across it now quickly. So the management part includes medical nutrition therapy and the use of drugs for diabetes control. Okay, sort of a struggle. So medical nutrition therapy, usually if you are a patient and you think like, no, what is it that I'm supposed to, I should avoid sugar, I should avoid something else, or I should avoid rice, and the answer is that there is no real thing which you should actually avoid. You should ensure that there is an appropriate calorie intake, there is appropriate timing and spacing of meals, macronutrient distribution is adequate, you see to it that there is sufficient fiber content and micronutrient sufficiency. You could use some non-nutritive sweeteners. So if these broad principles in diabetes care are adhered to, diet is nothing very challenging, and this can be done by most people with diabetes. In addition, you have to see to it that you do both aerobic physical activity of moderate to vigorous intensity, at least 150 minutes per week. Additionally, you should do resistance exercise and flexibility and balance training to see to it that you have muscle strength. The anti-diabetic drugs, I just try to put them across all of them. This is not for you all to know. You should know that today we do not have 1 or 2 groups of drugs. There are 5-6 big categories of drugs, and they have their own roles, and they have their own specific roles, not only for glycemic control, but for other complication or end organ prevention of damage. So that is what the physicians have to look after. These are the types of insulins that we have. And the current goals of treatment are, most patients we expect an A1C target of less than 7. So again, I'm saying those who have and who are looking after individuals with diabetes as your family members, please see to it that your individual's A1C is less than 7, at least once in 3 months. Yeah, thank you, sir. Let's hope that we can do a better job. And 7% is the standard goal for everyone, and if someone has short duration of diabetes, long life expectancy, no significant cardiovascular disease, so early on, someone is developed diabetes now at the age of say 45 years, then you say that I want a target of less than 6.5. Rather, today's world, I would be saying, let us reverse the diabetes in that guy. or that person. And someone who has had diabetes for long-standing duration, has multiple comorbidities, multiple complications, then you can be ready to see, individualize the target and say, let's keep it between 7 to 8%. So that is also not shameful. That is not going to be extremely more harmful, because there is evidence now to suggest that if you try to go really vigorously after them, you would rather cause harm rather than benefit. So this is what the ADA also said, the same thing. So where would you go for more stringent care, and where would you go for less stringent care based on disease duration? Longer the duration, less stringent it will be life expectancy. If you are already 75, 80, 85 years, then you would say, okay, let's make it less stringent. Someone who has more comorbidities, less stringent. So everything in that order. So these were the other things. Besides diabetes care, while glycemic control is the cornerstone of the management, you have to remember that you have to look after blood pressure control and get a target blood pressure of less than 130/80. And LDL, current guidelines say that you should target an LDL less than 70. People who just have diabetes in absence of cardiovascular disease. I thought there was one more slide. Okay, that's lost somewhere. So now, Dr. Anand wanted me to tell you all about something like precision medicine. Like we looked at, most of the time we looked at diabetes as a sort of a type 2 diabetes as a sort of one group, and we gave them the drugs which I alluded to, just like that. So times have changed. There is now the group of type 2 diabetes is sort of broken up into another few categories, and there is some evidence from the Swedish cohort here. This is again machine learning, which try to show that the type 2 diabetes is not one homogeneous group, but you can actually segregate them into 5 clusters, and some of them were the severe autoimmune group, some of them were severe insulin deficient, insulin resistance, and the milder groups. So what they found was that those who had this insulin deficient group, they had more diabetic retinopathy, and those who were insulin resistant group had more diabetic kidney disease. So that means going after the albuminuria in this group or going after a fundus in group is paramount. You're going to miss them if you do not look after them very vigorously. And in this group, using insulin sensitizers is going to make a big difference. Getting their weight down is going to make a big difference. So this is how you look at precision medicine in diabetes today. Ensure that your drugs go in the right manner to the right person. Do not give it as general way. The way we used to do it might be 10 years earlier. The same work has been replicated in India by Dr. Mohan's group, and what they found was that the groups here, sorry, it's my mistake. Yeah, so the insulin deficient group is there, insulin resistant and obese diabetes is there. So there's another group which is slightly different. There's a group which is insulin resistant and insulin deficient combined. Now this group has a lot of complications, and what exactly we need to do with this is recent data which has been published, so we are not really very sure how to deal with this cohort. Time will obviously tell us what to do. So these two parts were about, the second one was about the management. Now I'll come to the last part, which is about the solutions in terms of the system to the diabetes epidemic. And this would sort of interest people who are sort of, the directors of some institutes or whatever. If you have your dispensary running and you have individuals with diabetes in your sort of members of the staff, then how do we improve their care besides providing a doctor, a physician? So that's what is the challenge, because diabetes care involves much more than that. So one thing is prevention. So if you had individuals who were, say, either having pre-diabetes or overweight or obese, or women who had previous gestational diabetes, these individuals are at very high risk for development of diabetes, and hence an attempt should be made to prevent diabetes in them. This could be in the form of lifestyle modification or drug therapy, and it has been shown by a lot of studies that it is not only effective, but it is efficacious in terms of cost efficacy also. Means in the sense, it is not loss of money or waste of money to make an attempt to prevent the development of diabetes in this cohort as compared to any other group. So this has been shown world over, and there was one study from Dr. Ramachandran in the year 2006, what is called the Indian Diabetes Prevention Program, and that also showed that lifestyle intervention as well as metformin would result in a significant reduction in development of diabetes in people with pre-diabetes. So now those who have diabetes, what we find in the Western world is that almost 60% of the people have HbA1c more than 7%. So this is for people who have diabetes in the Western world, and they are almost like, if you see, 12% population has A1C is more than 10%. And when we did work on cars, we found the same type of numbers. It is much more worse than that. So, and this is despite having all the drugs, all the insulins. So where is it that we failed? And how do we address these issues? So the reasons for poor glycemic control are either patient factors or the healthcare providers. And the patients are obviously lack of knowledge of the patients in terms of the disease and how to tackle it. Poor compliance to lifestyle modifications as well as drugs, because people do not take diabetes as a part of their life. They look at diabetes as something aside. So if they go for a function, then they would eat as if they were non-diabetics. If they, some members, someone came to their house, yeah, I'm seriously saying this, if someone, a guest came to their house, then they would try to pretend that as if they are non-diabetics. So that cannot happen. You have to adopt a lifestyle for diabetes, which is actually a healthy lifestyle. Poverty, advanced disease, these also are patient-related factors. Healthcare providers, their problems are, they genuinely do not have time. Like in our clinic, we spend almost 6 hours, 7 hours trying to address these issues. But it is not possible in a busy outpatient setting to give even more than 3 to 5 minutes for a patient with diabetes. You end up only seeing their reports and then writing a prescription. So how do we address this? Lack of time, focus on drugs only. So you would hardly find clinics which have non-physician healthcare providers, inadequate information and inertia to reach the target. So if this is the thing, the first thing would be to make people educated about diabetes so that they can be a partner in the decision making, and they can have problem solving behaviors. They can play their own role in their care of the diabetes. So that as a result, at the end of the day, you can have better clinical outcomes and quality of care for life for these individuals. And there is it where you get the role of someone called as a diabetes educator. Diabetes educator or a care coordinator is a non-physician healthcare provider who can be trained to look after diabetes and support the patient in individualized education, promoting behavioral change, and to deal with the challenges of diabetes in their everyday life, to help them make decisions in their diabetes care, and as a result act as a facilitator of change in these people. So this is what a diabetes educator should be doing. The other role is of health technologies to help again. So technologies could be anything. Besides medicines, everything else would be still considered technology, devices, assistive technology, techniques, everything, to again improve the quality of life of people with diabetes. So, and why do these two things have a role, as I said, is because physicians don't have time, patients do not have education, NCD is a big problem, and so everywhere, and you need a team-based care. There was one slide which I was supposed to talk about, STENO2 trial, which tried to show that, it is not only about diabetes care, it is about diabetes, glycemic control, hypertension control, lipid profile control, it is about getting weight reduction, it is about getting, seeing that you take antiplatelet measures, and if you did all these things, then you get the best outcomes. So as a result, both of these make it almost very crucial that a diabetes educator as well as health technologies are ingrained into diabetes care. Oops, so was one more slide here. Okay, so this was the CARS trial which was done by Professor Tandon. I was also part of this trial, and we tried to So what we did was, there was one more slide in between which got lost out about the decision support system. Decision support system is sort of a software which tries to give prompts, tries to tell, okay, you need to screen this person for this thing, you need to do this thing for this person, or this person is not done this thing, like trying to see and giving inputs to the non-physician healthcare provider to get that information passed on to the physician. So that was taken, and non-physician care coordinator was taken, and the health technologies were taken. So to test whether this is more effective in reducing CVD risk compared to usual care. And this was done in tertiary care settings, 10 sites across India and Pakistan. More than 1,000 individuals were enrolled, and this is how the flow occurred in CARS. This is one of the first studies which involved CDSS, and like normal flow would be, patient would come to the clinic, get registered, do this, everything, and go away. The care coordinator saw to it that he or she coordinated with all these things, ensured a follow-up, gave lifestyle advice, gave reminders and advocacy for this thing, and the DSS gave prompts to say to the physician, hey, this A1C is more, you do something about it. Or do you want to change? These are the medicines available. Hey, the LDL is high, why are you not looking at it? Please make the changes. So this is what CARS, the translation trial was all about. And the results was that, so in the intervention group, if you see the multiple risk factor control was seen in 17% compared to 7.5% in the usual care. So that was a significant difference, the treatment effect. And individual cares like A1C less than 7%, blood pressure less than 130/80, and LDL less than 100 was also significantly different between the two groups, indicating that CARS trial told us that if you got EHR-DSS, you got a non-physician care coordinator in the management of diabetes in a tertiary care setting, then that would result in positive outcomes. I'm sorry, it's not wanting to move. Okay. Yeah, I think this is okay. So the only other conclusion we tried to draw out from that study was low cost diabetes care model. This can be replicated at primary care centers and other low income settings. So just to say that it may not be only in the tertiary care settings, it may work even in the primary care settings. So in Goa, so this is one of the last slides. In Goa, what we try to do is, so since I was part of CARS in the country, I said, let us try to replicate that model in Goa, but in a primary care setting. And this is what we did in the Changing Diabetes Barometer program of the government of Goa. In the version 2, we put up 15 CDCs, community diabetes centers. In that, each one, there was a trained diabetes educator at each center, and they tried to give what is called as comprehensive diabetes care, including diabetes self-management education, fundus photography, albuminuria screening, and food care. And we have data. We're just talking to Praveen, and we hope that we can analyze this data and then publish it to show that does the CARS model work in the primary care settings. So we'll get an answer to this very soon. So the take-home message from my lecture here is obesity, diabetes, and cardiovascular disease are major problems, and there's an ongoing epidemic. It has a profound effect on society in terms of the health of the individuals, the economic burden, and everything else. And how do we tackle it? Is it preventive strategies? And definitely, I believe. And comprehensive diabetes care, including diabetes educator, or care coordinator, and EHR-DSS. Yeah. Thank you for your kind attention. I'm sorry.
Thank you, Doctor, for the very informative talk on this lifestyle disease. The inputs were very useful to all of us. I now request Dr. Asta from IGIB to present Dr. Ankush Desai, a potted plant in appreciation and with gratitude. Thank you, Doctor. Thank you, Asta. The next speaker is Dr. Anurag Agrawal, Head, Quetta Center for Digital Health at Ashoka Dean, Biosciences and Health Research, Trivedi School of Biosciences, Ashoka University, and a former director of CSIR, IGIB. After completing graduate medical education at AIIMS, Delhi, he further trained in internal medicine, pulmonary disease, and critical care at Baylor College of Medicine, Houston, USA, followed by a PhD in physiology from Delhi University. His primary research is in respiratory biology, and his broader interests are in a new vision of health and healthcare seen through the lenses of emerging technologies. He serves on numerous national and global advisory groups, recently chairing the World Health Organization Technical Advisory Group for Viral Evolution. He received the Shanti Swarup Bhatnagar Prize in 2014 and the Sun Pharma Foundation Award in 2020 and is a fellow of the Indian National Science Academies. The topic of his talk is on digital transformation of health, the need for better data ecosystems. Over to you, Doctor.
Thank you. I guess you can all hear me. First of all, I must say it's a pleasure to be here back in Goa again. I think R.P. Singh, you had this wonderful memory of the healthcare theme talk in 2020. In fact, I got reminded, so in fact, I could find the slides. So then we were talking about serving, saving, learning, and earning, right? I mean, that's what CSIR healthcare theme should be about. And one of the things that many people don't know is the UK Biobank today makes a huge amount of money. The data contained inside the UK Biobank is so valuable that drug companies, to access it, pay a very significant amount of money to the UK Biobank. It's no longer costs them money, it makes them money. The question then is, can we create those types of data ecosystems that enable research around the country, at least down the line, might potentially become self-sustaining and add discovery and improve the lot of the human race. And that's what these 4 words were about. And this is actually a slide, R.P. Singh, from that meeting. So it's very, very nice to be here again in Goa. Of course, that meeting was not in NIO. That meeting, I think, was in a hotel on the beach side, right? वो beach side अभी तक याद है. So in any case, this is how we started imagining this back in 2020. Partho mentioned very correctly, Partho is not here, but he mentioned very correctly we started thinking about it well before I presented these slides at the directors meeting. So we were thinking about the fact that only CSIR amongst all organizations has the ability to build something like this. And Dr. Mande, of course, the then DG, was very supportive of the idea. But let's switch gears now. Let's switch to digital transformation. India is one of the shining lights in this world in digital transformation. But this is also India, and this is also India. And digital transformation is the culmination of 3 different steps. The first is called digitization. All your work is analog, and then you go around digitizing it, which basically means you have no quality assurance. You have to trust whatever you digitize is correct. The second level is digitalization. In this, the point of origin of data is digital to start with. There is a much higher degree of quality assurance from the beginning. And most hospitals like this can easily be digitalized. Settings like this are currently being digitized, but hopefully will move toward digitalized. But the last bit, digital transformation, is about ecosystems. It's about a vision in India of the National Digital Health Mission, now called the Ayushman Bharat Digital Mission. It's about everybody having an ID, everybody having a digital life, and health being just one bit of it. And let's take a very quick look at, even within this vision of digital transformation for a country like India, there are 2 very distinct themes. On the left-hand side, you see digital transformation in terms of eligibility, benefits, identity, service, records, access, empowerment. All this is good. But on the right-hand side, you have a different type of digital transformation. The genomics, AI, ecosystems. On the left, you have the medicine of today delivered better. On the right, you have a better medicine of tomorrow. You should not forget the right when you look at the left. And most of what I will talk about today will be more to do with the right, although I will touch upon the left as well. India is so far ahead compared to at least other comparable socioeconomic nations in terms of digital transformation that we are seen as the beacon for all this work to occur. If you look at ABDM, every person will have a number, every provider will have a number, every facility will have a number, every procedure will have a number, all claims for a procedure done by a provider at a facility to a beneficiary can be claimed by digital payments of UPI. And you can do all this via apps. It's already happening. So nothing that I'm saying here on this slide hasn't happened. It is just that the ecosystem we live in does not benefit much from the grassroots ABDM. And of course, India as such has users. There is a reason why we are approaching one of the highest economies in the country. We are already number 3 in the world. Of course, our numbers are also very high. So per person it is low, but digital enablement of the individual has made them seek services. And this seeking of services along with initiatives, and particularly if you heard the last talk, the rise of non-communicable diseases is going to make a massive amount of difference in the way the world operates. A wearables company, a health company in India called Goki. Goki creates smartwatches, advice, diabetes management, fitness management, has recently been contracted by the National Health Services of UK to keep diabetics out of hospitals and manage their diabetes. Again, some of these companies are finding better markets outside when it comes to paying customers, because the insurance payment from the government is too small right now to attract the bigger players, but that too will change with time. But let me say what I mean by digital transformation for today's talk. When I say digital transformation, I mean the intersection of the digital revolution, the genomic revolution with health, healthcare, health systems, and even science. That's what's really the 4th wave of digital health that we should be thinking of in institutions like ours. And Viren, when he gave his talk, told you about the fact that the majority of the people of the CSIR cohort had poor lung function. So I introduced a few slides to let you know how interesting this is. The word he was saying that you may or may not have heard was vital capacity. The vital capacity of the members of CSIR cohort was very low compared to expected. Why was it called vital capacity? John Hutchinson, who invented the spirometer in one version, found that people who had small vital capacity, the total amount of air you breathe out after a full breath in, died faster. So he called it vital capacity for vitality. He proposed it could be used to give insurance to people, the ones whose vital capacity is low, ask for higher insurance payments. In any case, a few years later, all of you have heard of Framingham. All the obsession about cholesterol started with studies from the Framingham study, where they found that people with high cholesterol developed heart attacks faster and died faster. Guess what was the strongest risk factor? Was it cholesterol? No. It was vital capacity. This is the risk of a heart attack. This is vital capacity adjusted for height. This is males. These are females. You can see small vital capacity with no other illness was a stronger risk predictor of future heart attacks than cholesterol. It was the single largest risk factor. Only problem is you can't change it. If you can't change it, no pharma company can make drugs for it, so nobody bothered to give much attention to it. Take another study. These are people with small lungs. Gold one, we can prevent it from declining, effectively increasing it. But I'll come to it. These are people with small lungs, restricted, and gold one are people with COPD. This is survival. Who dies faster? People with small lungs died faster than people with actual COPD. What they die of? Diabetes, heart attacks, strokes, COPD, all these things. So the question then is, why do Indians have small lung function, and what can we do about it? All of us reach peak lung function around 17 to 22 years of age, after which we lose lung all the time. So if adult Indians have poor lung function, either their peak was low or their decline was faster. There are only 2 ways to get there. So we started looking at adolescents, less environmental exposures, and we found that there was less effect at the time when you are still very young. Faster decline seems to be the issue. So if you want to improve lung function for people as a whole, slowing down the decline is probably the most important thing to do. But even within children, in this study, which we did for about 2,500 kids across the country, and these are, like I said, 12 to 17-year-old kids. Right now, they've not started smoking, they've not picked up any other habits. Right now, many other occupational diseases have not started. And what we could see is pollution was not the key factor. But yes, we could see that South Indians in general had slightly worse lung function than North Indians. North Indians had worse lung function than people from the Himalayas area, the more Asian side. But more importantly, we could see 1/3 of the children, irrespective of the location, genetics, and socioeconomic status, had poor lung function, probably because they were very thin, they had very high levels of inflammation. They also had more GI symptoms, they also had anemia, but these are all boarding school children in Jawahar Navodaya Vidyalaya. So probably it was chronic infections of the gut. And we spoke a lot about microbiomes when we started. So my point being, under the government's ABDM schemes, you can measure a lot of things. But to understand what you measure, to figure out what you need to do as a nation, you still need research studies. Just collecting data during routine clinical care, it's good, it's vital, it's an important step, it's necessary, but it's not sufficient. That's where research level data generation starts, and that is why I'm so glad that the CSIR cohort has become a reality. So if we look forward 20 years, what are the big things we expect to see? Big biomedicine, reading, writing, editing genomes, AI-driven discovery, and P6 medicine. DG ma'am spoke about P4 medicine. The 2 extra P's I've added here are psychosocial. Today we're realizing mental health is as important as any other health. And last, public health. Even in public health, you can have precision. All through the pandemic, what we were trying to do was precision public health. So precision does not only need to be for personal health, it can also be for public health. Together we call it P6 medicine. So big biomedicine is what you're trying to do. You're trying to generate data at scale. There are multiple initiatives. You're trying to understand the building from the blueprint and the bricks. It's nice, that's a good direction to go, and that's what scientists do. The other side of genome editing, gene editing, again, CSIR is taking the lead in India. The work of Shavik, Devajyoti with CRISPRs to do gene editing. India might soon become one of the first countries outside the big Western Europe countries to actually do gene editing for sickle cell disease and thalassemias. So it's great, we are there. But again, a lot of data needs to be generated. By the way, for those of you who didn't know, today you can create an artificial bug. An E. coli was created entirely from synthetic DNA. So in theory, as you learn and more from microbiomes, in theory, if you could design a bacteria, you could create it, you could give it life simply starting with the nucleic acids. So all that is possible. This is a story I really want to mention. We always think of mutations as bad things. The people on the 2 left, you all know, Charpentier-Doudna. They got the Nobel Prize. Because you got a bad mutation, you want to correct it. Everybody knows that story. What about good mutations? There must be good mutations as well. So Helen Hobbs looked for black people with low LDL in the state of Texas. Now the diet of Texas is not conducive to low cholesterol, and the diet of Afro-Americans in the state of Texas is even less conducive to low cholesterol. So when you find people with low cholesterol in that state, perhaps they have a genetic mutation that was good. And she found a mutation in a gene called PI-CHeCK. The fastest I've ever seen a drug emerge out of a genetic study is this. Within a few years, and of course remembering, correcting a gene is far harder than killing a gene. Making a protein work better is far harder than blocking that protein's action. So what Helen found was a mutation that made the protein non-functional. That we are very good at doing. Find something to block it, find something to kill it. So PI-CHeCK inhibitors are now in clinical practice. If you are one of those unlucky people who has very high cholesterol but cannot tolerate statins, your doctor in India will also put you on a PI-CHeCK inhibitor Unfortunately, you'll pay $1 lakh a month for that privilege. It's an injection that you take every month. But in monkeys, a single gene therapy at the liver level, 3 years later, the monkey is still on a high-fat diet, had low cholesterol and no atherosclerosis, and it's still going forward. I'm going to switch now to something that's really important in terms of data ecosystems, AI. All of you have heard this all through last year. If you take the minimum definition of a doctor to be a person who can clear the exams that test your ability to answer questions, well, then AI is doing better than humans. GPT-4 in particular can score around 86.7%, so can many others by Google, and that pretty much puts them in the top range of what human test takers take. Purely out of scientific interest, not because I wanted to cheat, to maintain my American license, I have to answer 30 questions every 3 months or so, and always remember on the last day, and I'm a good test taker. GPT-4 was beating me hollow, and these are specialized questions with full clinical scenarios. But then doctors think, where is the problem? Somebody's going to have to enter all that information now, because the question already contains the information. But to get that information from the patient, you need a doctor to ask the question. Here you go. This is called AMI. AMI is the Articulate Medical Intelligence Explorer, entirely trained on synthetic conversations, not real conversations, synthetic generative conversations, but it learns how to talk like a doctor for a variety of different cases. It can hold an entire interview. It was tested on 100 objectively structured cases with patient actors. So you're on a telemedicine thing. On one side is a real doctor, one side is Amy. A patient actor is on the other side. So they don't know whether they're connecting to Amy or to a real doctor. And another doctor will look at the final record of the discussion and the final management, and they will decide and they will rank on whether the diagnosis, top 3 diagnosis was accurate, whether the management plan generated was correct, whether the escalation recommendation, you need to go see the emergency room right now, is accurate, and the patient actor will say, how was the empathy of the doctor? Did you perceive openness and honesty from their side? So specialist doctor rates here, patient actor rates here. One of these is the AI, one of these is actual human doctor. And this is done in India, Canada, UK. You want to guess which one is the AI? This is the human doctor, that is AI. AI does better than the human doctor on almost every single count, but the best one is empathy. Empathy, it just beats the doctor hollow. Now that makes no sense. Ask yourself, what does empathy mean to you? The doctor was kind. He gave you time to ask questions. We just heard the previous talk. They are overburdened. They can only give 3 to 5 minutes. How will the patient feel like the doctor has empathy when they only get 3 to 5 minutes? So this is where we are with AI. But imagine the amount of data for health systems, even to generate those conversations was required. And in your own language, all this was English. Tremendous amount of data is required for India to do this, and we certainly need it. Even in basic biology, AI is helping. Generative AI can not only create sentences, it can create new proteins. What is a protein but a language of amino acids? It's already learned, it's happening. This is Demis Hassabis, very, very famous in the world of AI. He created deep learning for all practical purposes. This is his quote recently. So Google spun off Isomorphic Labs. It's a new alphabet company. They believe it will have more value than most things in time to come. AI will prove to be the right method for understanding biology, because biology is too complicated for humans to do it. And that's a reality. Look at most projects. Everybody makes somebody the hero, somebody the villain. The nuances of biology are often lost in trying to simplify and reduce the problem. Perhaps he's right, perhaps he's not, but that's where we are. P6 medicine. This is from the New England Journal of Medicine. They talk about how very soon we'll be at a point where we use massive data crunching using algorithms we no longer understand. To be very honest, people are surprised. How will doctors use something they don't understand? Always tell them, we use aspirin. We haven't understood aspirin yet. I mean, if you really look at it, do we know why aspirin is better than Brufen? We don't actually, for a heart attack. So I don't think doctors not understanding what they do is the problem, as long as the evidence generation around the practice is strong enough. But again, new systems will need to emerge so that the data is generated. I don't want to tell you here that AI is great, it has solved all the problems. I'll give you a few instances. One instance is something as simple as this. In India, in healthcare records, no doctor actually enters the drugs in the drug section. So we work with a company called My Healthcare, and you were there with us. So all the doctors enter their notes in the other section, other note section. So even if you want to read the medication, you have to extract them from the notes. You can't read them off the medication section. So a typical doctor's note might look like this. This is a great note, by the way. You're lucky if you have data that looks like this. But you want something like this, the name, the dose, the strength, the frequency, the duration, right? And these are the correct answers. Now you ask a large language model to read this and fill this out. See, it hallucinates. There was no D-rise. There is no D-rise anywhere here. It already decided there is a D-rise capsule once a month. Problem with LLMs, current AI is they hallucinate. Problems with the previous one is you have to tell them exactly what to do. And all of them are terrible in our own language. So this is at their best in English. Here, by the way, we got much, much better after we tuned them. So this is work we are doing at the Cohort Center for Digital Health. Right now we are running around 2% hallucination rates and 99% accuracies. And the hallucinations are minor, that's why it's 99 and 2. But sometimes AI can go terribly wrong. In America, they say your only real friend is your insurance company. They're the only ones who want you to stay healthy. I had a line, insurance company who plan to pay. So insurance companies who plan to pay are your real friends. They want you to stay healthy. So in America, they generate a score. If the score is high, they mean you are high risk of falling very sick, and they'll call you for special care. This is the score. This is parameters that determine how sick somebody is. These are blacks and this is white. You can see for the same score, a black seems to have to be sicker than a white person. Why? Do you think the AI is biased against black people? Do you think the AI favors white people? Very unlikely, right? Do you think the programmer introduced a deliberate bias to give his people, probably white people, a better chance? Unlikely. Data bias. What data bias? Define very sick. If you were to define sick people with cancer as people requiring hospitalization, you go to a government hospital and a private hospital. You look at the size of the tumor on the government side, look at the size of the tumor on the private side. You might suddenly, if you are an AI, didn't understand society. You might think, oh, these people need to have a tumor of that size to get admitted, right? Imagine algorithms like those running in the Indian data ecosystem without high quality, calibrated, consistent data. So data on which you will train AI cannot be the routine healthcare data of India. It has to be quality data that is consistent. So all those efforts we need to do to generate it are very, very important. There is a paper that just came out last week in the New England Journal. I won't speak too much about it. It's about medical artificial intelligence and human values. Human values are only understood by humans. They aren't even logical. Don't expect a logical system to learn human values. Many values we hold dear, there is no logic to it. That's what we have decided as a society, that's what we shall do. So training these algorithms requires us to continuously input the human values, understand where AI will fail, and generate substantial data. In India, there are lots of cohorts, but Phenome India is special. Genome India will do whole genome sequencing, some others will do human microbiomes, many are doing pathogen genomics, but only CSIR Phenome India has the deepest characterization and follow-up potential. For all the reasons speakers who came earlier today spoke about. I will not repeat the points. I cannot see any other cohort in India that will even begin to compare in terms of depth and imagine from day one, which makes it much better than many other places. Doesn't matter. The only slide I had after that was talk about the fact that no matter how well you collect the data, how well you do the study, in the end, the analysis will make the difference. And the analysis will make the difference only when you have even more data than your own to validate the idea that you generate. And if you notice, there was a last slide, engagement with other cohorts, engagement with other people, and I would encourage Phenome India as it goes forward to continue on that line. Ultimately, the nation needs a better data ecosystem. Multiple people contributing to this ecosystem will allow us to generate and test hypotheses crisscross with each other and find robust, valuable results. And it's wonderful to see people like Kumar who have the expertise in dealing with these data at scale. ICMR right now is putting together something like IBDC. All study funded by ICMR now will have to deposit their data. Not only will there be data research deposit, there will also be data research management at the time of giving grants. It's an area where I think every arm of the government is thinking about very, very seriously. I honestly think CSIR will take the lead on the science side, and I wish you all the very best. Thank you.
Thank you, Doctor, for introducing and elaborating on digital health and the future of medicine. In appreciation, I request Dr. Vamsi from IGIB to present Doctor with a potted plant.
I think I should give it to Vamsi.
Thank you. As we end this program, a big thank you to one and all. As the saying goes, health is wealth. We wish that Phenome India goes a long way for the benefit of our Indian society. Thank you. Jai Hind.